Good morning, sir. Dr. Pendalia, sir. Your voice is not coming. You are not audible.
Yeah, good morning, Dr. Patel.
We'll just wait for 1 minute.
Yeah, sure.
Okay, sir. Shall we start, Dr. Pendalia?
Yeah, sure. I'm ready.
Okay, thank you. So, good morning, one and all. Present here in icSoftComp. I welcome you all to the second day of this 2021 third International Conference on Soft Computing and its engineering applications. Today we have 3 invited talks and 5 technical sessions in this track 1, and there are 2 technical sessions in a track 2. So today first we have invited talk, and this speaker of first invited talk is Dr. Vishnu Pendalia. He is working with San Jose State University, San Jose, California, USA. Title of his talk is Machine Learning for Societal Improvement, Modernization and Progress, as you are seeing on the screen. He is like ACM Distinguished Speaker from 2019 to 2022. He is also Chair and Vice Chair Secretary of IEEE Computer Society SUV chapter. He is like a Board of Directors, Silicon Valley Engineering Council from 2018 to 2019. He is Executive Council member of SIG Computer Society of India from 2016 to currently. So I formally welcome you, sir, and I hand over this control of this session to you. So you may start, sir.
Thank you, Dr. Patel, for the kind introduction. Good morning, everyone. Machine learning for societal improvement, modernization, and progress. This is the umbrella topic under which I'm pursuing various ideas related to machine learning. It is also the title of my upcoming book that I'm editing. Of course, I will not be talking about the book itself, but a few applications which fall in the broad category of the title. So this book is being brought out by IGA Global. You can check out the call for chapters, and if you like, you can contribute to it. So machine learning is the motor of modernization and is driving innovation and progress of civilization. We all know that. Machine learning will continue to be a key economic driver, and it is really an exciting time to be working in this area. So if we look at the Google trend for machine learning, uh, so Google computes the trends for some of the concepts, and see the machine learning as a field of study. It computed the trend over the years from 2004 to July 1, 2021. And you can see that machine learning had a long winter, and it really picked up in 2015. And if you look at July or August 2019, it's almost touching 100. That means the interest level is 100% in machine learning. It went down a little bit, but it is still in its peak of research. This can be better explained using what is called, oh, by the way, this is for USA. And if you look for India, it looks a little different. The entire worldwide, it's the same. It's more or less the same. Yeah, worldwide is the same. But if you look at India, looks like there was quite some interest in the beginning of 2004 and stuff like that. Probably the 5G project that was taken up significantly by TIFR and others in India. There was a lot of interest even during 2014. If you look at the graph, it's a little bit different from the worldwide trend and the trend in USA. From 2004 to 2008, there was quite a bit, 2009 actually, there's quite a bit of interest in machine learning. So this can probably be even better explained using what is called as the Gartner's hype cycle. So this is the Gartner's hype cycle for emerging technologies. Just in case you are not familiar with this, the emerging technologies are classified into four or five phases, 1, 2, 3, 4, 5 phases. Starting with innovation trigger, there's an idea that's coming up, and then that's how the innovation triggers, and then it goes through a peak of inflated expectations. There's a trough of disillusionment, then there's a slope of enlightenment and plateau of productivity. So machine learning is in trough of disillusionment today. So it's in the process of settling down. People have come to terms with what is possible with machine learning and what is not. This is probably the best time to be working in machine learning. It will be another 2 to 5 years. If you look at the color code, the light blue is 2 to 5 years. So it'll be another 2 to 5 years for machine learning to reach the plateau of productivity. And we should be able to make plenty of difference in these 2 to 5 years. So it's really an exciting time to be in the machine learning area. So these are some of the areas that I chose for my research, particularly. In general, there is a lot of interest worldwide in these areas anyway. Um, so most of us are teachers, and we need to eat our own dog food first, right? That's what they say. Machine learning is used ubiquitously, but is not so much used for research and education. So that is one of my main focuses or the focus areas of my research. The next one is Indian classical music. Indian classical music is a classic example of similarity-based learning. The teacher sings and the disciples try to be as close as possible. So they try to imitate the teacher, right? We all know that. So it was recently proved that all of machine learning, including deep learning, is similarity-based learning. Just like Indian classical music is similarity-based learning, entire machine learning, most of machine learning at least, has been proved to be similarity-based learning. Uh, so this was proved by basis of kernel machines. So the other area is in the NoSQL realm. Substantial amount of data today, such as that on the social media, is in the NoSQL databases at the backend. The triple stores in semantic web also can be thought of as a special case of graph databases, which are a type of NoSQL databases. So there's a need to explore more ways of leveraging this data. Currently, we are only using REST API to get the data in the NoSQL databases at the backend, and then trying to uh, do some language modeling and stuff like that, NLP techniques, and then trying to extract value from it. But there could be more ways of handling the NoSQL databases. So that is the other area. And machine learning awareness needs to increase, just like computer awareness 2 to 3 decades ago. I mean, 2 to 3 decades ago, computer awareness was spreading, and so much so that it got into the school curriculum, kindergarten to 12, K-12 as it is called, K-12 curriculum. So for machine learning to get into K-12 curriculum, the narrative of machine learning needs to be simplified so that more and more people can understand machine learning. So that is the other area that I am focusing on. So the first is machine learning for research and education. These are some of the ideas I wanted to pursue in this direction. First idea is to help authors like you and me evaluate their work before submitting it to a journal or a conference. So the tool will help the authors determine their chances of acceptance, the paper acceptance, before they can submit it to any conference or a journal. The tool will also help editors choose reviewers and automatically evaluate the submission. So we are primarily using what is called as LSTM for the work. You must all be knowing about LSTM, which is a type of recurrent neural network. LSTM basically models how we read and comprehend. We all know no one reads a newspaper for more than 10 minutes, right, typically. But we are still able to capture all the news in the newspaper. How is that possible? So this is possible because we know which words to ignore and which words to read. So LSTM pretty much models this behavior through gates. It tries to determine which words to forget, which words to carry forward, and so on. So the system in this case comprehends the research papers, just like human beings capture research papers or newspapers for that matter. And then this system predicts chances of their acceptance. The next task is to generate analogies. Analogies are important in trying to understand a new concept, right? For human beings, we all rely on analogies. Um, so we are trying some NLP techniques to generate analogies automatically. So initial results are not very encouraging, but we plan to investigate further. The other area is question answering. Many years ago for my undergrad senior project, I used artificial intelligence to build a question paper setting system using Prolog. It was an expert system. Expert systems those days was one of the 5 primary areas of AI research. So I'm planning to do a similar thing now, setting question papers automatically, but this time using deep learning and NLP techniques. Stanford is leading the research in this area. They came up with a data set called Quad for the purpose of evaluating QA systems. And then Newer IPS, of course, Google is there in all NLP tasks, but Newer IPS, you all know this conference, the top conference of in machine learning, artificial intelligence. They host a competition in this area. So all interested can take a look at their website for details about the conference and also the competition. The another area, important idea in improving comprehension is to summarize text using images. We all know an image captures 1,000 words. It's as good as 1,000 words, or maybe even more. So there are what are called as stacked GANs, generative adversarial networks, which are used for this kind of a purpose, but the current solutions are just at the beginning. So the plan is to enhance the solutions or find new ones to do this. The other area is transcoders, right? Today, machine learning is able to predict the next word when we start typing a message in a natural language on the phone or wherever. That's called federated learning, right? If it is on the phone. So we should be able to do similar things with programming languages as well. So the next idea is to work in the direction and also to translate programs in one language to the other. Facebook already has a solution, but it works only to some extent and to only certain languages. Like I think they support C++, Java, and probably one other language. They use self-supervised learning to accomplish this task. Uh, Self-supervised learning is pretty much unsupervised learning, but the Facebook researchers like to call it self-supervised. So we made some initial attempts to generate R code from Python, but I think we have a long way to go. But efforts are in that continuing in that direction. So Google AI has this natural questions. So if you go to their website, you can see them on the browser window that I'm sharing. So they collected questions. These are real questions asked by users of Google. Um, so when users use Google to search the internet, they typically write questions, right? So those questions are captured, and that's why Google calls them as natural questions. Google is anyway increasingly being used for question answering, right? Thanks to NLP pre-trained model that they invented called BERT, B-E-R-T. So this BERT model allows us to use transfer learning for NLP, just like we use ImageNet for computer vision, right? So that is one pointer for those who are interested in building a question answering system. And the other pointer I have is, of course, the Stanford's work. Oh, one second. So this is Stanford's squad question answering dataset. Pranav Rajpurkar and others came up with this dataset using crowdsourcing. They also have a leaderboard where they track the performance of the question answering systems. And right now, this is where we stand. This is the baseline. This is what Rajpurkar and others obtained in 2018. But right now, it has improved a little bit, quite a bit, I would think. That is about Squad. And this is Facebook's transcoder project, so which converts one language to the other using self-supervised learning. Um, so they have a page for this, and they gave some examples of code conversions and things like that. There's also a paper, so if those interested can look at the paper as well. So the next topic is Indian classical music, right? So using deep learning for Indian classical music. So there are two ideas that we explored. First is converting melodic frameworks of Indian classical musics from one to the other. So we actually converted North Indian ragas, um, Hindustani music to Carnatic music, which is South Indian music, using deep learning. So that's one idea. And the other idea is building a music tutor. So that is an ambitious plan, but we are still working towards that. Um, the next idea is simplifying the machine learning narrative, right? Machine learning, we all know, is increasingly becoming ubiquitous, just like computers started to become 2 or 3 decades ago. So incorporating computer literacy and software skills into K-12 curriculum, we all know yielded positive results. So nurturing machine learning savviness among K-12 students should have a similar or even better potential today. So for the past few months, I have been teaching students as young as 8 years old on how to prepare for the software industry, and also giving them insights into machine learning concepts and things like that. So actually, there is a huge 5 million grant from the state of California for incorporating computer science skills into the school curriculum, the K-12 or the kindergarten to 12th grade curriculum. So there's a huge task efforts being put into this, but we want machine learning also get into that stream. The focus is only on computer science, but I think machine learning should also get included. So that is one effort going on there. And The next idea is spirituality. There are many similarities between spirituality and machine learning concepts. For instance, the word hari, right, in Sanskrit means to reduce. Harna means reducing, right? So this same concept is used in machine learning, and it's called regularization. We reduce the weights. In spirituality, we reduce the weights we attach to the happenings in the world. And in machine learning, we reduce the weights that we attach to the features of the data items. So exploring in this direction may yield newer techniques that can be adopted for machine learning, right? As our Vedas and spirituality have a lot to offer to the mankind. So they haven't been explored yet. So adopting some of those techniques into machine learning might be useful. So that's the other area I'm trying to look into. So whether all these materialize or not, I am still going to write a textbook to simplify the narrative using metaphors. It will be published by Taylor and Francis. It is scheduled to be out towards the end of 2022. Um, so NoSQL, like we talked, we want to see how best to use the data that is in the back end of many of these websites, social media websites and things like that. So that is the other area. It is still in preliminary stages. But I just wanted to cover one interesting area, which is the generative adversarial networks. This is a key technology I want to use in quite a few of these projects that we talked about. So there's a whole lot of generative adversarial networks currently in existence today. So there's something called somebody has put up a zoo there, the whole zoo. So these are all the different types of GANs, generative adversarial networks, that are coming up by the day actually, or by the week. So you can see the interest growing exponentially. These are the number of papers that are getting published in the area of generative adversarial networks. So I just want to take one such type of generative adversarial networks that we use for the project, and that is called the cycle GAN. So the original cycle GAN was used to convert between similar looking images. For instance, in this case, cycle GAN was used to convert from horse to zebra. So for that kind of a problem, we would have needed several paired examples in the training data set to train a machine learning model. But getting that kind of a data may not always be possible, right? You need tons of pictures of horses and zebras and map them together and all that stuff. So that's a bit expensive. So that's where cycle GANs help. Cycle GANs learn the mapping between an input image and an output image without needing any paired training examples. So instead, they use what are called as cycle consistent adversarial networks. So a subsequent paper also applied cycle GANs to music, but we used cycle GANs for converting ragas in North Indian music to ragas in South Indian music and vice versa. So cycle GAN has last year in this same conference, icSoftComp, I talked about generative adversarial networks, and generative adversarial networks have two components. One is the generator and discriminator. Cycle GAN has a pair of such generators and discriminators. So you can see one pair is in pink here. One pair is in pink here, generator and discriminator, and the other pair is in green here. So the first pair works to convert music in a North Indian raga called Bhairavi to a South Indian raga called Shanmukha Priya. And the second pair does vice versa. So the generator discriminator pair works just like before in generative adversarial networks, except that instead of random noise to start with, we input original music notes in Rag Bhairavi. So you can see the original music notes in Rag Bhairavi in color yellow. So that is the, instead of noise, we actually pass the original samples. then simple adversarial laws like computed in generative adversarial networks is not enough. So we compute cycle consistency laws also to determine how different the generated raga is from the original sample. So the cycle is shown in these arrows. The thick arrows denote the transfer from Bhairavi to Shanmugapriya, and the regular arrows denote the transfer from Shanmugapriya to Bhairavi. So generative adversarial networks bring together two powerful paradigms together, right? The deep generative models and adversarial learning. So they are really powerful, and we plan to use generative adversarial networks for many more such conversions and things like that. So all this work would not have been possible if it was not for my students. They do all the experiments, taking directions from me. I come up with the ideas, but they do all the experiments. And my sincere thanks to Dr. K.K. Patel and others at Charusat, Charotar University for giving me this opportunity. I'm really glad to see the conference grow through the years. I had the pleasure of speaking at the conference all 3 years since the conference has been in existence. So the first time was in person, and hopefully I'll be able to deliver the talk next year also in person as well. You're welcome to collaborate with me on similar or completely different projects related to machine learning. My details are given on that website, San Jose State University's websites. And I am on social media. That's my Twitter handle. I'm on LinkedIn and everywhere. And I'll be glad to answer any questions.
Sir,
Yeah.
Yes.
are you able to hear me?
Yes, Dr. Narasimha.
Since you mentioned about two topics, one is Indian classical music, another about the Veda. I would like to ask you the following. See, the Carnatic music, one of the thing is in the Kriti Rag, I don't know music, there, whatever be classical, you have the freedom to slightly modify it to your way. Or to give example of Karnataka, Kannada, I don't know about your Telugu grammar. As an example, when you put the Sanskrit words Antar and Rashtriya, you do not follow the Sanskrit exact Sandhi. Instead, you put it Anta Rashtriya, called Shrutisaya Sandhi. Now the question is that in your deep learning in music, or it comes again in Veda pronunciation, the Nambudri tradition of Kerala versus the Smarta tradition of Karnataka. Now, are you taking care of this, rather putting some of these in your machine learning? I have
Yeah,
put two independent things, I am sorry, but since they are similar in spirit. One is in the music, in Karnataka music, that Raga Bhava, certain kind of thing they say, a outsider will not know where he break the exact rhythm and modify it to your expertise. The same thing if you were to look at in Veda, the pronunciation of specific suktams in the two places. So I was pondering whether you are using, rather considering them in your deep learning.
Yeah, that's a good question. So as you know, machine learning is basically inductive approach, right? We don't specifically give the details. We don't mention the details like you mentioned, the tone and so
Professor
all those.
Pandiala, probably we have to go outside this in case somebody else wants to ask question. But the thing is that if you were to look at in terms of Sandhi, in grammar, one can in principle put it in deep learning that here are some of the things where this particular language has this tradition of moving it, rather modifying it. The same kind of thing in principle in Carnatic music. Suppose one were to look at Lalgudi Jairam's some of the things were a little bit, I won't say deviation, going superset. of that what he tried. So in principle, one can try to see where exactly it will lead to if you were to use deep learning there. I don't
So the,
know. This is not my field. I am only asking you since you have done the work and you are an expert.
yeah. Get what you say, what you mean, but so the way we train the models is in an inductive approach. We dump a bunch of samples at the machine and then let the machine do the analysis, learn the patterns using recurrent neural networks, right? In this case, particularly, um, we just uh, generate an intermediate um, what are called as the piano rolls, intermediate form of music, which is in form of piano rolls. And then the system analyzes those piano rolls and then is try to, based on the loss computation and back propagation and all that stuff, it is able to learn, right? So it is more of an inductive approach. We don't specifically say, okay, this is Rag Bhairavi, so this is a parent raga, and it should have these notes in it. We don't do all that. We just dump a bunch of samples and let the machines analyze that. Now, coming to your Sanskrit thing, I don't know where the confusion is, but what I mentioned was I'm trying to compare the concepts in spirituality with or Vedas, or for that matter, any other scriptures, with what is in machine learning. So I'm trying to do a comparison, and the idea behind that is to see if we can adopt any of those concepts from the Vedas and the ancient scriptures into machine learning to make the models better. So that is how I am investigating. I'm not really looking at the chanting or the tone of recitation of the Vedas, and that is not the approach, and that is not the idea here.
Okay, and thank you, Professor Pendian.
Thanks.
Sir, I have one question. Sir, how you maintain the database for this task?
For which specific task?
For this proposed system, your task.
No, there were a few tasks, right? There were quite a few tasks that I talked about. So I don't know which one you are referring to. So is it one of these tasks, or you generally want to know how I maintain the data?
Yes. For musical systems, relate with this ragas and all. And I have another question. Suppose for a particular language song, suppose in Hindi we have some song, so it takes 5 minutes for running, and when you convert it in another language, how much time it requires? It takes same 5 minutes or else?
Yeah, it takes the same 5 minutes. So the most of the stuff will remain the same, just that the genre of the in this case, if it is images, then the genre of the images change. In this case, it is changed from horse to zebra. In case of music, it will be changed from one raga to the other. Um, so we looked at the spectrogram and chromogram, and it appeared that um, the music generated is quite close to the one that we expect. So that's how we determine.
Sir, what
And
main
in terms
features you take for this, consider for this?
of what features for the music thing,
Yes, for music and for this image also. So, according to object, your features will be changed. Na? So, you have any list for your object selection, or you are working on only two or three particular topics?
So that is the beauty of deep learning, right? We don't have to really bother about features and things like that. Deep learning automatically generates the features, right? We don't have to do any feature extraction manually. Deep learning handles it. The only thing that we do is convert the music into piano rolls. That is the standard way of handling music. For uniformity, we just convert it into piano rolls and then do the processing.
Any other questions? Very quick questions. No questions. Okay. Thank you, Dr. Pendalia. You have discussed a very good topic on like machine learning for the societal improvement and modernization and progress. And main one thing that you have discussed, that is using machine learning for the research and education, in which one system that you are working on, that AI-based research review supports and rating, which is really useful for like the conference organizer who wants to use this kind of system, that is a research review support and rating. So if you need any kind of input for that system, then we are like very useful for you that. Thank you very much, sir, for discussing different aspects of AI and machine learning for the societal improvement and modernization. Thank you very much, sir.
Yeah, thank you. Thanks for the opportunity.
Okay. Dr. Trivedi, are you there? Kiran Trivedi? Just a minute. Dr. Trivedi, Kiran Trivedi.
Yes, sir, I have joined. Actually, it will show you my son's name, Nisat Trivedi.
That's why I have used little bit. Okay, no problem. I am making you the presenter.
Yes, sir, no problem.
I think you joined as a guest, huh?
Okay.
Okay, now you are the presenter, so you can share your screen.
So let me share the PPT.
Besides the leave button, there is a one button with a up arrow.
I'm sharing.
Okay.
Is it visible, sir?
It's visible.
Hope it is all visible to all of you and in a proper format of 100% in the screen, right?
Right, sir.
Okay. So,
Make it full screen.
okay.
Okay. Open with age. Okay, sir.
Good morning, all of you. I'm very happy to be part of the icSoft 2021 conference, and I'm very much thankful to uh, Charuset University for providing me this opportunity to deliver a talk in this session. So, we are moving towards edge computing in terms of implementing all the machine learning methodologies on a small hardware. And specifically, why we are doing this, we need to have a kind of concern of further security. Usually, what happens that most of the AI processing or maybe the data or models which are running on the cloud itself. But now this is a time that we need something by which we need to have our own model on our own device. Say, for example, Amazon Alexa. Amazon Alexa is nothing but a best example of edge computing, like Google Home and all these are the best example of the hardware software, which actually we call as an edge computing. So what happens exactly in the edge computing? Let me tell you. On the
Dr.
right side, yes,
Sorry
sir.
for intervening. If it is possible, then please turn on your camera.
Okay, sir.
If
That,
possible, then
yeah, yeah.
because it's like useful.
Is it okay, sir, now?
Yes, sir. It's okay. Fine. Thank you. Continue, sir.
Yeah, I need to come back to my. Is it visible?
Yes, sir. Everything is fine.
On the right side of the screen, you can see a very small hardware, and there is a Arduino Nano BLE33 Sense. This is a very small hardware. You can call it like a 1-inch small hardware, which is capable of running machine learning model. These days, we run lots of models on our computer systems, or maybe on the servers, or maybe on the cloud server, which are a little bit bigger in size. Say, for example, 100 MB of model, or maybe 200 MB of model. But when it comes to edge computing, the biggest challenge is to convert them into a smaller size, and it should run on the hardware itself. So, as we know that these sort of hardware are having a limitation in terms of flash memory, and it is very difficult to run. But that is why, like TensorFlow has come up with number of conversion of the models, and that is why we are able to convert the model into the hardware. So whenever we create a model in terms of any of the machine learning, using any of the machine learning algorithm, we are capable enough to transform or to port this model onto a hardware. So today I'm going to discuss something about a kind of a edge computing, how we can start, what are the different features available, and how to do that. I will go through all these slides very quickly because we have a shortage of time and it is not possible to cover everything into this. So it is also known as an embedded machine learning. So whenever we try to port the model on a small hardware, it is a standalone kind of a thing which does not require any internet connection, which does not require any cloud support. That is what the embedded machine learning is all about. Say, for example, you have a Raspberry Pi, you have a Arduino Nano 33 BLE Sense, and if you want to run a machine learning model directly on that, it is nothing but a tiny machine learning, or we call it as an embedded machine learning. So we need to keep this fundamental rule by Jeff Beer, who has given a kind of a blur word for that. So the important thing what we need to keep in mind is that it should have a proper bandwidth. Latency means whenever you are providing some input data and the model responds from the hardware. So how much time it takes to respond that. So latency is also very important. Economics means the price of the hardware should be very low. It should be reliable and there should be a privacy. So if you compare all these BLERP with the Amazon Alexa, it is the best one. Whenever we say hello Alexa or Amazon Alexa, we call it with the name, it immediately responds. So the latency time is very short in terms of providing you the responses. Now, what are the things what we get in terms of physical computing? This is also known as the physical computing concept in some of the US universities. In India or abroad or globally, we call it as an edge computing. So why do we need that? Because ML models are getting smaller due to development in advanced libraries. See, why this is happening? Because, you know, there is a lots of development in terms of microprocessors which are capable enough to run the machine learning model. We have a kind of a huge library support, which is an advanced one these days. And most of the microcontroller boards or maybe the development boards are becoming more and more powerful. And the best example of these devices are what we have already talked about, that Alexa and Google Assistant. But you can also make your own Google Assistant on Raspberry Pi. You can also make a kind of an Amazon Alexa device on any of the hardware available. And the biggest advantage of economics is that like all these boards are very low cost. Say for example, 3,000 rupees for Raspberry Pi or maybe for Arduino Nano, it is 2,200 rupees. So we can have our own hardware which runs on an edge computing model. It reduces latency, conserves bandwidth, improve privacy, and enables smarter application. That is what the beauty of edge computing is all about. So how to kickstart? just you need to buy this board. For example, if you want to start with the edge computing at your own, on the Arduino's website, you will be able to buy the Arduino Nano 33 BLE Sense, which I have given here, and we can start working on that. What do we need for that? We need some softwares like whatever normal softwares, Arduino IDE or Google Colab, just to write and run the program, because we need to do that on our machines. Even though if you don't want to do anything in terms of installation of the softwares, I will also show you today a best platform these days, which is highly popular, which is known as an Edge Impulse platform. So in today's session, what I'm going to cover is like introduction to machine learning, transfer learning, and classification. Some of the things I will skip because I want to directly show you, looking at the time constraints of 20 minutes. So I will go to that slide first. So what is possible with microcontrollers in machine learning? That is what the important thing we need to understand. What sort of models we can build, or maybe we can modify some of the already available examples for the computers for our hardware. So, you know, like this particular hardware is having speech, gesture, image, pose, sensor data classification, and lots of things which we can do. The sensors are on board on the development board itself. Okay, so I will also suggest all of you to refer this book. This is one of the only book available in the market right now, which is written by Pete Warden, who is from Google and who is working on the tensor. Yes, sir. Who is working on the machine learning models for the tiny devices or the hardware, and they call it as a tiny machine learning methodology. It is available in the market also, but I have got a specimen copy from the author itself, Pete Warden. So if somebody knows, let me know. I will share with you. Okay. So these are some of the concepts which I'm quickly skip, but I will directly jump to my hardware, which I want to show you. Okay. Okay, what would be the flow of the ML projects with what we do for the tiny machine learning device or edge computing device? First of all, we need to decide the goal. We need to collect the data set, design a model architecture, train the model, convert the model. This is fifth number is very important because we need to convert the model for the hardware and then run inference and evaluate and troubleshoot. That is what should be the flow for all these devices. And the important thing is, in terms of any of the area in the world of science and technology, the creativity is very much important. So how much creative you are, you will be able to create applications or case studies or use cases for that. So this is one of the example of machine learning where there is an Arduino board, and whenever you switch it on and off, it will automatically do it from the sensor itself. So it understands the gesture of the person, and finally it gives you the output in terms of the physical computing device. This is another very interesting use case of physical computing, that a lady is wearing a dress, and based on the lunar star positions, something is displayed because it has been trained like that. So this is also, I have also given the link for everything. Whenever I will share the PPT, you will be able to get them. This is something about by pressing a simple button on this, taking the gestures from the hardware accelerometer, and it will give you the output in terms of the screen. This is something very interesting game which kids play, like rock, paper, and scissors. You need to simply show your gesture like thumb and two fingers and the complete palm. That is what the output will, the arrow will move based on the gesture of the person. So that is what the interesting application of that. And these are some of the boards which I want to discuss. So Arduino Nano is not only one board. The biggest player today in the market is by NVIDIA Jetson Nano, and that is what the board is all about. And a very popular example is the JetBot AI kit, by which we are able to make an autonomous vehicle. So these are all examples of the edge computing. This is again a very popular board, Raspberry Pi, which if you connect the camera with that, you can make a complete computer vision system. But important thing is we need to run the model on the Raspberry Pi, and Raspberry Pi is not that much capable enough to run that. But sometimes if you want to have a very higher mathematical calculation inference model, at that time you can even connect a USB stick which is having a GPU capability, and in the market there are lots of sticks available by Google and Intel. I will also show you that thing also. Okay, and this is one of the very much interesting ready-made kit available on the Amazon website, which we can buy. It is available in India also. So, for example, if you want to guide some student for edge computing projects, the Vision kit provides you a Raspberry Pi and a camera. Voice kit also comes up with a speaker and the Raspberry Pi. We need to simply train the model as per our requirement, and there is a very good step-by-step documentation is also available by which we can create, and it comes with a corrugated box also, so directly we can utilize it for various applications. Say for example, if you want to use the Vision kit and if you want to make a kind of an attendance system in the classroom, that by taking the photograph of the student, you want to take the whether the student is present or not in the classroom, simply take one photo of the classroom as a group photo, and it will identify all the students from that if you have trained the data accordingly, and it will create an Excel file, and it will enter all the absence and presence of the student. So these are some of the case studies of this sort of Vision kit. This is also one of the powerful board. If you want to replace the Raspberry Pi and if you want to go for a kind of a board which is specifically designed for machine learning application, it is known as a Google Coral board. It's a development board and it is having a USB accelerator too. So you can connect the USB accelerator with the hardware and you can definitely run your lots of machine learning applications on that. This is also very popular, but it is made by Google. That was by Raspberry Pi Foundation. Now coming back to our main board, which I want to discuss today. This is again an interesting one which is available on the SparkFun website. This is by Adafruit company, and this board has a onboard display also and onboard microphone also, which you can use for making a voice-based application. Say for example, if you want to create a translator, which is an AI enabled, so create some model, somebody is speaking in Gujarati, and if you want to translate them automatically and display on the screen, you will be able to do that. So a kind of a micro speech example which is available on the guide of this particular board, you will be able to deploy and run quickly. That is what the interesting example of it. It's a very small board which comes with a battery and microphone and display. So this is by Adafruit. This is also coming, it's a kind of an head for the Raspberry Pi. So head is nothing but a kind of an additional board which we can fit on the Raspberry Pi if you want to make it enabled with the camera as well as the display. And this is what the interesting board which I want to discuss today, because I have this board and I have worked on this board, and this is a very interesting one because it's very low cost. Again, it has lots of sensors which no other board in the market is having. So what are the different sensors on board available? It has 9-axis inertial sensor. So it means that it is an accelerometer which gives you acceleration in X, Y, and Z direction. It provides you gyroscope value in X, Y, and Z direction. It provides you Earth's magnetic field also because it has a magnetometer inbuilt on that. It has a humidity sensor, it has a temperature sensor, it has a barometric pressure sensor, it has microphone inbuilt on the board itself. It has a gesture sensor also. So gesture means like if you move your hand like this from left to right or right to left, or maybe take it closer to the board or maybe take it far away from the board. You might have observed this sort of sensor in mobile phones, like Samsung Galaxy S4 and other variants had this sensor of the gesture, that if you want to move the photographs from the gallery, you need to simply move your hand on the LCD screen and it will scroll the photograph. So that is a gesture sensor which is also on board on this. There is a proximity sensor that it gives you a kind of a object proximity to the board. It has a light color sensor and light intensity sensor also. Say for example, many of us might have worked on the object detection, and maybe we want to classify the fruits. For example, we want to classify banana and apple and orange. So we may use camera for computer vision application. But say for example, if you don't have a camera and if you want to classify these fruits, whether it is banana, whether it is orange, whether it is apple, so what can we do? At least we can train our model with the color of the fruits, and at that time this sort of board can be very useful to us, that like it can identify the colors. So train the data with the colors of the fruits and create a model, and simply putting the board close to the fruits will give you the output that it is banana or maybe it is an apple or it is a orange, something like that. Even the light intensity sensor will also help you the daytime movement, daytime light condition, and it will allow you to identify whether it is a kind of a sunset time or a sunrise time, because it is totally different. The morning light and the evening light is totally different. So yesterday I was talking to one of my student as that just by looking at the photograph of sunset or sunrise, can you identify whether it is a photo of sunset or sunrise? It is very difficult for us, because whenever somebody shows us the picture of a rising sun or a setting sun, it becomes difficult for us even that, because we as a human are having a cognitive sense that just by looking at the position of the sun, we are able to understand that, okay, if it is in west direction, it is sunset, or maybe it is in east direction, it is sunrise. So at that time, we need to create something interesting by which we are able to identify the light intensity, and based on that, we should be able to identify whether it is sunset or sunrise. So we want to make machines more intelligent than the human, and that is what the overall effort is all about. Okay. Now talking about some memory on this board, it has a flash memory of 32 KB, an SRAM of 2 KB, flash memory of 1 megabytes, and SRAM is 256 kilobytes. So now you can understand that if you want to run a machine learning model on this Arduino Nano BLE33 Sense, it should be less than this, otherwise it will not run. And whenever we convert the model using TensorFlow model conversion technology, we will be able to convert it into a 20 KB of memory only. So that is what the most powerful thing, that we might be having a 14 GB of data set. Whenever we create a machine learning model in our computer that is of 100 MB, and finally converting them into a very smaller model which can run on a hardware, and that is of 19 to 20 KB. So bringing all these 14 GB data into a very small model of 20 KB is what is an interesting technology what we are in the era of. Okay, so even we can connect the camera with the board also if you want to make it a computer vision enabled application. That is what the thing is we need to understand. Okay, see, this is an example of speech inference example that, say for example, if you want to identify the keywords, say TensorFlow has a very good example for yes, no, A, B, C, D, left, right, up, down, etc. The keywords which has already been trained, and there is a model available. And if you want to deploy that model, you can directly do and run it on the Raspberry, this one, Arduino Nano 33 BLE Sense. So the speech inference example can also be run on this. This is an example of TensorFlow which you can use in mobile applications. We are not interested right now into that. Okay, so on this board, I have actually set some color codes for that. That if you look at the screen on this particular board, we have an orange one, which is color brightness, proximity, and gesture sensor. So in a very small, tiny area, these are all surface mounted devices. There is a digital microphone in a blue box. There is a motion, vibration, and orientation sensor. There is a temperature, humidity, and pressure sensors. All are on board, and there is a Bluetooth capability also. That is why it is known as a BLE. BLE is basically Bluetooth low power protocol, which is being running in the board itself. Okay. Now I will show you some example. Okay. Now when we want to run this board, we need an Arduino interface or maybe an Arduino IDE to run that, and that will allow us to write the Arduino code for that. So those faculty or students who is well versed with the Arduino, writing the codes for them, it is very easy to write the program for that. But only thing is that where is our model? Where is our model where we can include into the Arduino file? Because whenever we'll burn the code onto the chip of the Arduino board, we need a header file. So in this example, the header file is basically the model. So whenever we write something like include model.h, so model.h is basically our model which we have trained and converted for the Arduino using the TensorFlow library. Okay, and these are some of the libraries we need to install for running the Arduino for our machine learning application. So for Arduino Nano, we need some IMU libraries, that is for accelerometer, something for microphones. Similarly, we have libraries for gesture sensor, we have libraries for pressure sensor. Let me tell you a use case of one of the gesture sensor example. Say for example, I want to create that just by moving my hand, I would be able to convey some message. I want to create some text. So what I will do is, say for example, I have done one, maybe I'm writing one in my in the air. I do it for 100 times, like 1, 1, 1, 1. I will collect all the data for accelerometer for gesture 1. Then I will do 2. So I will collect 100 and thousands of data for gesture 2. So accelerometer will give me all the X, Y, and Z direction, the sensor position data, and I will collect those data. I will create my own data set, and finally I will make a model, and that model will be deployed on the Arduino Nano itself. And basically, whenever we wear that Arduino on a wrist, and finally if we do something, it will give you the output that it has according to the training accuracy, will give the output. It has also a kind of a proximity. So why I'm talking about all these sensors is that you have lots of options to create machine learning applications on this hardware. If you are interested in predicting the temperature and humidity of a particular city, collect the data for say 1 year throughout the year, and maybe create a model. It will predict something that, okay, maybe in summer you have this sort of humidity, or maybe the temperature can rise up to this much. Looking at the previous data, you will be able to generate the outcome, or maybe you'll be able to predict something. And now coming to the Edge Impulse platform, I will suggest all of you to go through this Edge Impulse platform. It is a very interesting one, and it will help you to quick start. Even those who are not much into the development of machine learning application will also get a chance, that it will help you that what sort of model you should use, what sort of training you should provide, how you need to split the data. All is available, like everything is available on the Edge Impulse platform. You need to simply be ready with your data set. So that is what the thing I'm going to discuss right now. This Edge Impulse platform will help you to collect the data also from the real world sensor. Say for example, I have logged into my Edge Impulse account on the website of the edgeimpulse.com. It will help me to identify the sensor which I have connected with my computer. If it is not available, say for example, you don't have a hardware and you have your mobile phone only. So the mobile phone too having lots of sensors inbuilt, and accelerometer is also there inside the mobile phone, and you want to create an application which is a gesture based. So what we can do is that this mobile phone will also be connected with the Edge Impulse platform. It will allow you to generate some data, and that will automatically come into your account of the Edge Impulse platform or the cloud platform. And on the website, then later on, you can train the model and you can deploy this directly on an Arduino device or maybe on the Android application. That is what the overall scenario of the Edge Impulse platform. So I have created some screenshots by which you will be able to see how Edge Impulse platform looks like, and will help you to create your machine learning application for edge computing. So just create an account on the Edge Impulse. Initially, it will ask you for a new project. Say for example, I have created a new project with any name. Then this is a very interesting part. I will little bit zoom it. It will ask you that what sort of data you have. Do you have an accelerometer data for gestures, or maybe any kind of an activity or a human activity recognition? All of us are well aware of the smart watches available in the market. Say for example, Apple Watch or a Samsung Watch or Fitbit or Amazfit Watch. All of them are having a kind of a gesture activity detection inside that, and all of these watches are running a machine learning model similar to the Arduino what we are discussing right now. So say for example, you are riding a bicycle, and within few seconds the watch will let you know that you are riding a bicycle, and it will start counting your kilometers and calorie and your number of data for the heart rate, etc. So how to do that? And that is why we need some sort of accelerometer data. So this Edge Impulse platform will allow you to select your data set. Say first is accelerometer data. Okay, that is fine. Now you are interested in creating some audio based application, that you want to create something by which you want to train with the audio data. Say for example, you want to identify the sound of a bird. Maybe in our ecosystem, we have lots of birds in our society or nearby areas. Maybe a sparrow, maybe a cuckoo, maybe hyena, etc. Number of birds are there. So there is a huge data set available by Google for birds classification using audio. So we can collect those data for the audio, and we can use it for the audio related application. If you have images, usual normal computer vision application, if you have images with you, you can use that data set also, or something else. This will allow you to use other sensors also. So this is one of the first wizard which will allow you to select your data set. Once you acquire the data, now it gives you two options. Either you have all the data set ready, available into your pen drive, or maybe into your folder, or maybe onto your Google Drive. It will allow you to take directly from the source. If it is not there, it will allow you to collect directly from the website itself. So here there is an option that acquire data. Let us collect some data. Click on that. It will ask you that which device you have connected with your computer. If it is a remote device, that is also fine. If it is a multiple devices, say for example, there is a research group who is working on collecting data at different locations in the world. Somebody is located in Delhi, somebody is located in Mumbai or maybe in Ahmedabad. All of them can contribute with the data, and that can be collected into a single source, source of storing the data on the Age Impulse platform. So that is also available. Now, second part is that once you have collected the data,
Sir,
you have an
sorry,
option. Yes, sir.
time is
Yeah, yeah. I will few 5 minutes. I will close it down. Okay, so now you have this option. Then after you need to do this thing. Let me directly go to that part. Okay, once you have created the model, it will give you a header file on the Edge Impulse platform. Download that and use it in the program itself. And this is an example of a sensor data of an accelerometer, which is shown on the screen. And finally, you will be able to create some CSV files, which is part of the data set. And similar, this sort of data can be collected from the Arduino for your training. And then finally, you can run on the hardware itself. So this would be the final steps that train your neural network based on your CSV data, randomize and split the input and output pairs for training, build and train the model, verify it, convert the trained model to TensorFlow Lite, encode the model for Arduino header file, and once complete, copy the contents of the model.h file to the model.h in the Arduino file. And finally, your edge computing device is ready. So this is what the overall picture is all about, which I wanted to discuss today. Sorry, I actually covered very quickly, but this will give you a hint that how you can start edge computing and create machine learning applications for the edge computing device. I hope it was useful to everyone. Thank you, sir.
Any questions from audience?
Yes, please.
Sir, I want to ask that Edge Impulse can be used for the blockchain implementation data analysis.
No.
No, it can observe the block generation mechanism.
No, there is no options for the blockchain right now on the Edge Impulse platform. It is mainly for the edge computing that its main target is to deploy machine learning models on the hardware, and there is a variety of hardware which are available. But definitely what you can do is that if you have any blockchain applications and you want to use it with the machine learning and want to deploy on the hardware, then definitely you can play around with the Edge Impulse platform and find out something by which you can use that platform.
Okay, and one more question is that any board is available for the data analysis for the security is higher or lower to observe that kind of thing using a ML model?
Can you repeat your question? I didn't get it, sir.
Sir, I want to ask that is that any ready-made board is available from that we can connect our database with it, that board, and we can observe that how much the data ratio is secure or not secure or the frequency and time consuming, that we can observe. That kind of ready-made model is available with that ML model, that kind of thing.
See, Age Impulse platform is not providing you any sort of model. It allows you to create your own model. That is what the
Yes.
first is all about.
Okay.
It supports lots of hardware, starting from Sony. I forget the name of that model. Sony has also provided a machine learning board by which you can deploy the machine learning application. Raspberry Pi, Arduino Nano, and Jetson Nano, and some other few companies' boards are available. You can see the target board on the website itself by which you can deploy your model on that. So based on that, you can check. Even it has a possibility of visualizing your data. Say, for example, you have created a model and you want to visualize your data about classification of the things. You can run them, even if you can remove the data, you can play with the output and increase the accuracy, and everything is available, which is not possible in our own scenario whenever we are writing the code in Google Colab or something, etc. And even it help you to customize the model also. Say, for example, once you have created a model or maybe the algorithm, you can go to the advanced option and you can change the hyperparameters, etc. And it will help you to modify that also. That is also available on the Edge Impulse.
Okay. Thank you, sir.
Thank you.
Any other quick questions? Okay, sir. So
I
we are
just noticed light is not properly on my camera, so maybe something dark is visible.
problems.
No.
For record purpose, like it's required to have this kind of screen and like recording, video recording. That's why I ask you to turn on your
Oh,
camera. Thank you, sir. Thank you very
thank you.
much, sir, for your you spare your valuable time. I know that you are very busy in government work, like of this. Now we have Vibrant Gujarat also. So I know that you are very busy in that, and although you spare your valuable time for us for IC Softcom, and you have discussed about how we can use machine learning for this edge computing, and mainly this kind of so your talk is like very informative talk for the researcher who want to use machine learning kind of things for the embedded system, and if they want to create or if they want to do the research in AI based automation, then it's a really useful things for them. So I really thankful for you to come here and give your talk to us. Thank you very much, sir.
And if anyone is interested in creating machine learning applications using edge computing, please feel free to contact me. My email ID, maybe I don't know whether it is available and I forgot to mention in the slide also, but it is krtrivedi@gmail.com. Anyone can contact me and I will definitely help you to do so. Thank you so
What
much.
link I will send you. No
Yeah,
problem.
thank you. I'm writing in the chat box, no problem.
That's good, sir. So,
Thank
sir,
you.
we are, with your permission, we can start our next technical session, that is S6. Sir, are you done?
Yes, 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 sir. You can start.
So I can invite the author of the first paper.
Yes.
I think Kavita Krishna.
Sir,
Kavita.
good morning. Good morning. Myself, Kavita, sir.
Okay, are you there? Let me
I,
submit.
sir, actually, can you make my student Sudhamshu to be the presenter, sir? He is also in the meeting.
What's its ID or name?
65, sir. 65, Sudhamshu.
Just a minute.
Yeah.
Good morning, Professor. I am Sudhamshu, by the way.
Just a minute.
Good morning.
Let me make you the presenter so that you can share your screen.
Yeah.
Yes, yes, sir. Yeah, that'll be great.
Okay.
Yeah. Thank you, Doctor. I'll be sharing the slides shortly.
Thank you, sir.
Thank you, sir.
Welcome.
So yeah, I hope the slides are visible, sir.
Yes, it's visible.
Yes, visible. Please go
Yes.
on.
Yeah. Thank you, sir. So good morning, everyone. I'll be presenting our topic, our work, which is how do we segment base maps from using object segmentation. So object segmentation, so I'll be covering shortly what is object segmentation. Base maps are essentially the prominent features of a region which do not change very often. So which are buildings, roads, they do not change very often. So we try to generate base maps using object segmentation. So quickly covering what our motivation was is maps, the satellite images have a lot of applications like agriculture, geology, etc. like I've listed here. But segmenting objects is one of those applications which we can use for generating maps. So maps generated quickly can be used for mitigating disasters. They can be used for analyzing the damage caused by disasters and so on. And base maps can be used for variety of applications like forest area analysis, road networks, and area covered by buildings and so on. So jumping on to the problem statement, so given input satellite image with some specifications, this is implementation specific. But other than that, we'll try to output a base map with 4 classes of objects, which are roads, buildings, greeneries, and water bodies. So that is the first objective we have. And the second objective is basically the accuracy. We try to do it with 85% of accuracy. And the segmentation outputs are colored with appropriate colors to give us inference. We humans can infer them better. So going on to the overview, so this is something like the overall picture of the system. So given an input satellite image, segmentation tasks will have masks which is black for the class is not present and white for the class is present. So wherever we have white, we have roads. The leftmost is buildings, roads, greeneries, and water bodies, and so on. And we are giving them appropriate colors. So blue for water, green for greenery, and so on, black for roads. So finally, we'll be combining all those segmentation outputs to give us the base map, which will give us information regarding that region. So this is an overall architecture. I'll be cutting it in 4 paths to simplify it. So first path is basically getting the satellite image from the user. It is sent to the server. So the driver function is important because it will follow path 2 to cut the images into tiles. So all of these tiles will be made to those black and white masks. So black and white prediction masks, they'll be predicted using the segmentation models. They'll be sent back to the driver function, where the driver function will send it to 3. Path 3 will color them with appropriate colors like blue, green, and etc. We'll be combining those to get the base map. And finally, it will be sent back to the driver function, which in turn will send it to the user as output in path 4. So this is an overall architecture system for that. So these are some design details. So delving into that, user interface is just basic HTML, the regular works, CSS, JavaScript. We use Google Earth Pro, which is an open software you can use for getting satellite images in real time. Flask for the server part, and to train we use Google Colab and some NVIDIA Tesla GPUs. So to discuss how we train the models to segment the regions properly, we have 5 modules split up. So basically data collection, data pre-processing, training, validation, and testing with real-time images, and then the user interface. So I'll be going in deep on each one of them. So dataset collection, we had buildings dataset. This was obtained from a competition of AI Crowd. So this has around 280,000 images of buildings and their masks in JSON format. So this JSON format is changed to mask in pre-processing, which I'll be covering shortly. The roads dataset has masks ready. We have masks, so this will be your input and this is your desired output. So you'll be training your segmentation model based on this. We have 6,000 images approximately here, 6,226. And as you can see, the building and roads dataset were binary tasks. The greenery and water body dataset is a multi-class segmentation challenge. So we try to obtain greenery and water bodies from one image. This is multi-class segmentation. So woodlands is 2, water is 3. We have labels for each of them. Here we are suppressing buildings because we already have a separate task for that. So this is about buildings, the dataset collection overall. To pre-process, buildings dataset and roads dataset are binary. Again, once I am highlighting that they are binary tasks. So MS JSON format annotations are converted to binary masks. This is using an API again. And we are resizing the images. And roads dataset, we are simply resizing. And we did find that this gave us optimum results for doing it. And greenery and water bodies dataset, we had to cut them because they're really huge images. We have 4,000 and 9,000 pixels of width. So we had to cut them into very small pieces. We had to one-hot encode them and one-hot decode them because we have labels in integers. So we want to convert them to arrays to train them properly. So coming to the training aspect, we have units which have proven to be fast for segmentation tasks. So we are trying to segment the 4 classes of objects. And we chose 3 architectures. So if you see your unit, you'll have on the left-hand side, you have your encoder and you have your decoder on the right-hand side, which is tweaked with respect to your encoder usually. So we have a simple unit architecture. So we're training 3 architectures here for segmenting all the classes. So we have a simple one, and we chose 2 popular encoder networks, ResNet 101 and VGG16, to compare and see which is giving us the best results. So for training and validation, we used some popular metrics like intersection over union. This is commonly found in your segmentation tasks. Pixel accuracy is the percentage of correct pixels you're getting. And TP, TN, these are what we generally know as true positive, true negative, false positive, and false negative. And loss functions, we have to minimize the loss functions. So for roads and buildings, which are binary tasks, 0 or 1, we use a binary cross entropy, a logarithmic loss, which is just for 2 classes. But for multiple classes, we use categorical cross entropy, which is another logarithmic loss function, but for multiple classes, which you can see, as you can see. And we have a lot of results here, but I'll try to cut it, to give a specific inference. So for buildings dataset, as you can see on the top table, VGG16, we found VGG16 to be performing better by a slight margin. And for roads, we found again VGG16 was performing slightly better on the grounds of IOU. And when we came to the land cover, which is greenery and water bodies data set, we found that ResNet 101 was performing better in validation on the grounds of accuracy. So this is overall results. We had compiled them into 3 tables. So we did train them with optimizers. Some optimizers were experimented here, ADAM STD, which is stochastic gradient descent. And we gave equal epochs so that we have a fair ground of comparison. So coming to the results, the user interface, this is just a sample we took from Google Earth Pro. And this is to the 1024 cross 512 is just an implementation specific requirement. This is a whole area. So what we get is this image. So it is going to segment all the greenery as green, all the buildings to red, and all the roads to respectively. So to conclude, we were able to successfully segment the 4 classes of objects with up to 90% of subjective accuracy. This was up to subjective evaluation. On validation, we did find them 85% was fulfilling. So novelty, if you see the base maps, they'll take a lot of time to be generated manually. So if you had to take volunteers, it will take a lot of time to generate these. But a system can generate really quickly. So this can be useful when you are trying to mitigate or trying to analyze disasters or areas, so etc. You can do anything with that in satellite images. And future works, this is definitely this can be improved. So there can be more data sets with more segmentation classes, which represent other classes of objects. You can also use different training and alternative pre-processing steps to further improve the accuracy. And maybe other techniques like image fusion, ensemble learning, they can be experimented apart from units. So these are some references. We also have included the the data set links. And before I conclude, I would like to thank Dr. Patel and Charusat University, all the organizers of this conference for giving us this golden opportunity to present our work. Thank you. We'll be open for questions now.
Thank you, Sudhamsu, for the nice presentation. It was indeed a very good work.
Thank you, sir.
I would like to ask you a few questions regarding this. The first is the source of the satellite images. You have used Google Maps, right?
Yes, sir. Yeah.
Can you tell me the way Google is actually generating the maps in terms of like whenever you are zooming it or zooming out,
Yes.
how the Google map is actually made up of?
I personally think that they use sensors like satellite sensors. They're using it, and if you can see in Google Earth, they have a vast data set. Like they have a vast amount of data. We can also go back to 1995 and see what the region looked like back then. So
Okay,
I'm
fine.
thinking it is purely,
Sorry to interrupt you. My question is all about like something like Google has actually created the Google map using different layers that you must be knowing. Say, for example, if you are at some say 100% zoom level, or maybe you go to 80% or maybe 60%, 50%, etc. These are all different images. So Google satellites or whatever satellites are and taking the or capturing the images are at the different levels, and then finally they combine all of them. So whenever we zoom it or zoom out, it actually gives us the proper output in terms of display. Now, at what level you have worked? That is what my first question is. Say, for example, you might be having 100% zoom and you have taken the closest image. So it means that you have gone up to that level and your model or whatever work will apply to that level of images only. Have you tried with different zoom level? Does it work properly?
So for that, we have specified a per pixel resolution, sir. So we'll need certain pixel resolution because otherwise, if you have to zoom out really far, you cannot do that because the model cannot identify it.
Cannot identify. Yes, that is what the thing. So to make it universal, for example, to make it universal,
Yes, sir.
maybe you must have come across using some another image sources. Like there is an open source data set for all the images, satellite images of the world. And maybe if you target some specific area, say for example, you are targeting Hyderabad and you have taken satellite images of Hyderabad. So you have a kind of a very huge file. Say for example, a single file containing 4 GB of data, and you need to explore all the different layers and finally you can do segmentation, etc., and you can create that. That is what a simple suggestion from my end. Another thing is like, have you worked about change detection into this?
No, sir. We
No, sir,
haven't
no.
gone to change detection yet.
Okay, so because like once you do a segmentation kind of a thing, and if you want to apply something that previously there was a road, previously there was a no road, but now after maybe 6 months there is a new road on that area.
That is
So
true.
whether the system is capable enough to understand that and to create something new out of that. So that is what the thing I want to. And what are the challenges you face during this or limitations of your work?
So the limitations would be we were not able to experiment a lot. So we were limited to some optimizers. We are limited by the metrics used. Also, when collecting the data, we had to cross through. We had to unify the data because to train them on a similar ground, we had to unify that. So that was some of the challenges. Limitations would definitely be the non-availability of extensive experimentation. We did not have that. So I would definitely say we can improve on that.
And does it work for any other areas which apart from your targeted areas of the satellite images?
Uh, Generally, it is intended for satellite images, sir, with certain resolution and certain height. Other than that, I think it doesn't work for any other. I don't get it properly, sir. What do you mean by?
Question is that like as you have used Google images, definitely on Google satellite images, and if you create a kind of the complete view of the satellite data, like there is a forest, there is a river, there is a road, there
Yes,
are
yes,
etc., then it is fine. It is very easy for us to identify those objects in terms of identifying or classifying them.
correct,
But
correct.
when we go to the raw data, at that time it provides you different pixel values. That is why I think if you have used that, definitely you would have got the option to apply it to any of the areas of the world. Your model can run on maybe on California also because that can help you, because maybe many a times it happens that on satellite images the houses and everything looks similar for us, but
Yes,
maybe
yes,
machine learning model it looks different. That should you need to test that. And
yes, yes.
another one is that last question to you, that like what is the annotation or labeling tool you use for that?
There isn't a annotation and labeling tool, sir. So this is simply what can I say? We are coloring the
Okay,
segmentation
you
outputs.
are coloring that. Okay,
Yeah,
fine.
yeah, yeah.
Okay. Thank you so much. It was an interesting one,
Thank
and
you, sir.
wish you all the best and you take it forward and
Thank you.
develop some interesting application out of that. Thank you so
Sure,
much.
sure. Thank you, sir.
Sir,
Thank you.
thank you very much for your suggestion, sir. Sir, currently we are doing the change detection along with the flood analysis with the current UG project.
Yeah, that is what we need
Yeah,
actually, because
yeah,
it's
yeah.
very even useful for the security concern also, because
Yes,
Yeah,
like Indian borders there are lots of roads maybe which were not previously there, and if somebody is making that sort of roads,
true, sir.
definitely the government should identify those changes at the border level, that somebody has made some road over there maybe from the nearby countries.
okay, the
Thank you so
actual
much.
challenge is dataset part only, sir, from the beginning. We didn't find a
Yeah,
proper
yeah.
dataset for all classes. That's the first challenge.
I will
So,
simply
yeah,
suggest you to
yeah,
explore other sources of the data also, because that would
sure,
help
sir.
you a lot to make it more like strong work on these areas. Google is a very good way to start with, but
Yes,
definitely there are other sources also.
yes, we have to try it out,
Definitely,
sir.
sir.
Yes.
Yeah, yeah, yeah.
Thank you.
Thank you, sir.
Sure, sir. Thank you very much, sir.
Thank you.
Thank you. Next paper ID is 085. So author of 085, are you there? Prabhat Kumar,
Yes, sir.
what's your
So
ID?
along with me, Abhishek Chaudhary is also here.
Abhishek Sharma.
Abhishek Chaudhary.
Abhishek Chaudhary, sir.
So what's your ID?
So 085.
Uh,
Very good.
login ID.
Very good. So I make Abhishek Chaudhary as a presenter, right?
No. You can make me present your Prabhat Kumar.
Prabhat,
237.
Prabhat Kumar. Okay, just a minute. 37. Just a minute.
Okay, sir.
Now you are the presenter, and you have 12 minutes to complete your presentation, so that we get 3 minutes for a question answer.
Okay, sir. So shall we begin?
Yes, your screen is visible. Turn to the presentation mode and start your presentation.
Okay, sir. Okay, sir. Thank you, sir. So good morning, everyone. My name is Abhishek Chaudhary, and joining me is a very good friend of mine and the co-author for this paper, Prabhat Kumar. We are here to present our research work for this paper, item number 085, which goes by the name of a CNN-based AI writing recognition framework for linguistic characters. So let's begin. Let's first talk about what is AI writing. AI writing is a practice of writing the linguistic characters in free space, utilizing the 6 degrees of freedom of hand motion. The video that you are seeing in the slide is the final interface that of the solution that we have proposed in our paper. And let's now talk about the challenges that comes with this AI writing problem. There are basically three main challenges. The first one is that since it is a free space, there are no predefined start or end points. And neither there is any fixed reference position for orientation of any virtual plane to write on. Second point is that the input for such system is highly variable with every user, as every person has its own way of writing any character. So there is no generalized way as to define as to how a character should be written. Third point is the extension of the first point. Since there are no predefined start or end points, thus there lies no standard protocol to guide the user's hand to follow a particular path. That is the trajectory mapping, basically. And so now let's talk about the motivation, the main idea behind this research. The main idea was that visualizing the unseen and the unspoken. Now, what do you mean by that? Let me just break it down real quick. According to stats, 15% of the global population has some sort of disability. Out of this 15%, 2 to 4% have a significant disability, which leads to which limits them from basic functioning of day-to-day life. Now, it is true that we cannot help everyone, but yes, we can help a significant few. So let's jump into our research. First, starting with is the literature survey. Now, the main reason of including this in our presentation is to highlight the main advantages of our solution over the past existing solutions. If we take a closer look at this table, we can easily see that the results produced by these systems is very impressive with a very high accuracy and a minimal rate. But there were like two main problems among all these four systems. There were first one of them is the hardware redundancy, and second is the build cost. Why build cost? Because all the systems relied on on some external expensive sensor, the depth sensor, kinet sensor, simple depth camera, leap motion, myo armband sensor, etc., etc. And due to this problem, the build cost also rises. Now, if the hardware fails, the system is completely useless. You have to install the exact same sensor because the system is calibrated according to that sensor. So this was the problem of hardware redundancy, and simultaneously giving rise to the problem of build cost. Now, moving on,
So
the
yeah,
data
I'll
set
take on from
description.
here.
Yeah.
The dataset description is as follows. The data used in our framework is AZ and Indian alphabets because there are a lot of less dataset available of small size. It consists of 26 classes. Each class is designated to letters from A to Z. They are grayscale images which have resolution of 28 by 28. And the characters are formed in this such a way that each character is centered to a resolution of 20 by 20. The data is split into 80-20%. It is for the training and 20 is for the testing purpose. Moving on to methodology, let's move on to deeper working of our algorithm. So first, the user starts the algorithm. It goes default into detect only mode. In detect only mode, we uses a generic camera, which is available on any device that you can find. So in detection only mode, user starts drawing in the air. Then user have an option to either save a drawing or not. If the user does not save a drawing, then it goes into detection only mode. If he saves the drawing, it goes into activate recognition mode. There are two modes here also that if we want to activate the recognition or not. If not, then it goes back into detection mode. If yes, then it goes into recognition mode and gives the character as output, recognized character as output, then goes back to initial state. For track and identification, so we can use anything for our tracker, and this is because for tracker we are using HSV color space to detect the tracker. For its segmentation, we are using three methods like masking the tracker using mask erosion and mask dilation. For trajectory approximation of the tracker, we are using contour formation of the mask, calculate the centroid of the contour, and tracking the centroid of the tracker to get its actual location on the virtual interface. And on virtual interface, we have two windows, live viewer and the windshield. Live viewer is shown in the first slide. And for the recognition, we have used CNN. The CNN architecture is as follows. It uses three convolutional layer, three max polling layer, and in the for a feature extraction block, and for classification block, it uses four layer. Each layer uses ReLU as an activation function, except for the last one, which is softmax function. So our model is trained on two different optimizers. Those are Atom and RMS Pro. The model A uses Atom as an optimizer and got accuracy of 99.75%. And model R uses RMS Prop, which got an accuracy of 98.17%. The losses and accuracies are shown in the table below. For each epoch, we train our model for 4 epochs of total. And moving on to the application and advantages, the application of model is to facilitate the Kuso effect among younger and older adults, and to aid and improve cognitive perception among young kids, to understand the scribblings by a hyperlexic child, and allow doctor to take notes while performing surgery where they cannot use conventional writing methods. So here are the references. All references are cited as in the same order to paper. Thank you. So we are open for questions.
Yes, sir.
Yeah, thanks for the nice presentation. Can you show me your first and second slide, please?
Yes, once.
Yeah, just go to the first slide.
Yes.
So what is the motivation of using the source of data set specifically for air writing?
Sir, as we have also stated this on our paper at the time of this when we were doing this project, there were not a lot of data sets available like the characters. They were either for integers, but a lot of work has been done towards the for the integers and numerals. But we wanted to try like endeavor to the area of this linguistic characters. So we could only find this one data set, that is the A to Z handwritten data set. So
Okay.
that's why.
Can you show me the
It is
slide?
like a combination of many data sets.
And can you
Yes.
show me that
One
slide
second.
where you are moving some or writing into air or something like that? Yes, this
Yeah.
one.
Yes.
One slide. Okay. So what are the factors which are limiting to this particular writing into air? Say, for example, the light condition, etc. Have you included into your work or not?
Sir,
Yes.
actually, for the segmentation, we have used HSV color space like we have told in the presentation while presenting. So what happens is we can use any color of for the tracker segmentation. The mask is generated and it will take only the hierarchical which has dominance of that color.
Okay. Can you go to the next? Next. Okay. And this is a kind of a normal OpenCV based application?
Yes, so OpenCV based application.
Okay, and into that, like what's particular functions you have used to write this?
Sir, we have actually used normal take the input from the camera, then we have just how can I say that we have done the erosion and dilation of the mask.
Yeah.
For the color space, we have tried to get color.
You have set any hotspot areas from where you want to start the first point?
No, sir, there are not any space. Like we can
It
start
works,
anywhere on the
works
surface
for
of the.
anything. Whether if I start from the top left corner also, it will identify. So the complete
Yes,
workspace. So the
Yes, sir.
complete workspace is considered. That is fine.
yes,
Yes,
sir.
sir. Except for the buttons area because they are specifically designed for that task that they are
In
given.
colors.
Like clear all will clear the canvas and blue, green, yellow are the color the change of the ink.
Ink.
Okay,
Yes.
that's very good. Now, what are your plans to take it forward?
So the currently we are face the limitation of our project is that it is only limited to that recognizing single characters. So we would
Okay.
really like to take it forward to like words so
You
that we
want to
can,
make
yeah,
words. That is what you
yeah,
think. That is what I
Yes.
wanted to do so that like it's very easy in a way that you identify the alphabets or something like that. But finally, we need words and the meaning of those words, and
yes, sir.
Yes,
maybe
sir.
some a spelling error or something like that. But it should identify. So auto-correcting the spellings and identifying those meanings, and that's an
Mm.
interesting. Thank you so much. I like this. Thank you.
Okay, thank you, sir.
Yes, sir. Thank you, sir. Thank you for having us.
Having us here.
Sir, you are muted.
Thank you, sir. So any question from the audience? Okay, no problem. So now we will move to the next paper, and the author of the paper ID 114, Indrajit Bhattacharya and Siba Kali Gupta. Are you there?
Yes, sir. I'm Indrajit Bhattacharya. Am I
Just
audible, sir?
yes, you are audible. Let me make you the presenter. Yes, you are the presenter now. You can share your screen.
Okay, sir.
You have to complete your presentation in 12 minutes. Huh?
Is my screen visible?
No. Yes, now it's visible.
Okay, sir.
Turn into the presentation mode.
Okay.
Please make it full screen. Yes.
So,
Visible.
myself, Indrajit. Uh, should I start?
Yes, you may start.
Yeah. So, myself, Indrajit Bhattacharya. I'm graduated from University Institute of Technology. Today, I'm going to deliver my topic entitled Intelligent Friendship Graphs Theoretical Framework. So by saying this topic, you may ask what do you want to mean by friendship graphs. So firstly, in this context, we need to understand the meaning of friendship graphs. From the social networking point of view, a friendship graph is nothing but an undirected graph where edges are bidirectional. Roughly around 2.91 billion users use Facebook on a monthly basis, which is an ideal example of friendship network, and it could be termed as Facebook friendship graph. We have emphasized the recent security-related issues of the Facebook network and proposed a unique encryption method of the original network. That is nothing but the friendship graph. In a study, Elgin demonstrated the mutual friend-based feature which must increase significant privacy concerns as a hacker could use it to seek out some or all of the victim's friends. These attacks could be referred to as the mutual friend based attacks. For example, if a group of attackers repeatedly attempts to breach the security of the Facebook network and somehow will break it, then due to this mutual friend based attacking trend, the users of the Facebook may always be at risk. Before forwarding towards our actual topic, I need to discuss some essential terminology, that is contraction. In our proposed work, we have delivered a unique encryption mechanism through an intelligent contraction method. In graph theory, edge contraction is nothing but the merging of two vertices in a logical manner. The ideal definition of contraction could be understood by the following figure, where we see that the vertices u and v contraction, we get new that is w, which is adjacent to all the neighbors of the figure under we see the vertex v want to contract, and the newer vertex v2 is adjacent to all the neighbors of the web diagram, that is v1 and in the diagram, adjacent to all the vertices where v1 and v2 are adjacent. So now we can understand this definition quite clearly, that G be a graph and E be the edge set of the graph VIV. Suppose the new vertex WIA, which does not belongs to not the original vertex set, now contract an edge E in the actual graph G results in the graph G/E obtained from the original graph G by removing an edge E, replacing vertices Vi, Vj, the original vertices in the graph, with newer vertex Wij, where Wij is adjacent to all the neighbors of Vi and Vj. In the upcoming slides, we have shown the graphical representation of the traditional contraction method, the conceptual model of intelligent contraction, and an illustration of our proposed encryption process. Now, it is the right time to to discuss the proposed conceptual model. To prevent the security-related issues of the friendship network, we have developed an intelligent contraction algorithm. We have employed the concept of maximum common neighbors or common mutuals of a vertex for contraction. The proposed contraction method consists of several degrees of contraction phases. Initially, we need to apply a pairwise partitioning algorithm to analyze all the relations of the undirected graph pairwise. The outcome of the pairwise partitioning algorithm is nothing but a partitioning table, which reduces the continual search of the adjacency matrix. Initially, we need to pass our original friendship network through the pairwise partitioning module to get the pairwise information about edges. Afterward, this information should be transferred to the first degree contraction phase, that is our initial contraction phase. By seeing this graphical representation, the understanding could be quite clear. First of all, we need to pass our original network, that is a Facebook friendship network, through the pairwise partitioning module to get unordered relationships pairwise. Now, the pairwise relationship actually passed into this first degree contraction phase, where we can apply our initial encryption. And initial encryption process, we have just encrypt those vertices with dummy vertices and then pass the encrypted network. Bypassing the hidden information means we have just masked the original vertices of the graph with a dummy vertex and passed to the next degree of to use the pairwise partitioning module again, and then towards the second degree contraction phase for contraction again and this is nothing but a continued contraction method. So the original graph has to be passed with multiple contracted layer, and until the algorithm will stop or we have reached into our desired contraction phase. Let us imagine a scenario that this is an subset of the Facebook friendship network, where I have shown names of my friends, and an attacker is trying to visualize or analyze some information from this network. In the given network, we can see that Shoham and Piyush having the highest degree ages. So according to our intelligent contraction algorithm, the algorithm will randomly choose Shoham as the initial vertex, and after the initial contraction, Shoham and Piyush will get merged, and the merged vertex in the same degree of contraction cannot be contracted within the same contraction again. After the first contraction, Shoham and Piyush, within the first degree contraction, the next contracted vertex will be Shankalpa and Anish, and similarly Indradeep and Rahul within the initial degree of contraction phase. Now the ultimate contracted graph has been passed as an input graph for the second degree contraction, where we can see the dummy 1, dummy 2, and dummy 3 as the dummy vertices, where the dummy 1 vertex denotes the contracted vertex Shoham and Piyush, dummy 2 as Shankalpa and Danish, and dummy 3 as Indradeep and Rahul. Now, this graph should be passed as an input graph for second degree contraction. And in the second degree contraction phase, again, the contraction algorithm works, where and according to the contraction algorithm, here the dummy 1 and dummy 2 vertices will get merged, and the merged vertex, and it should be replaced by again a dummy vertex, that is dummy 4, and it is the input graph for third degree contraction. Third degree contraction, and like this way it continues until we reach towards our final contraction phase, that is the 5 degree contraction phase, where we can see that is the only dummy vertex, that is dummy 6, which contains all the hidden information inside it. And by seeing this network, we cannot predict the actual network that has been referenced here, and this is the original network. An attacker, it is almost impossible for an attacker to predict this actual network by seeing this network, which has lost lots of information, which has been where the information has been lots of information has been hidden inside this network. So by seeing only this few information, it is quite impossible for an attacker to predict in real time. As we have mentioned earlier, that our conceptual model has been divided into several contraction phases, where each contraction phase returns some hidden information in the form of a table. A network administrator only knows this hidden information, but the attacker doesn't, as I've mentioned earlier. As the contracted network representation contains several dummy vertices, therefore it is very difficult for an attacker to realize the actual network without having the knowledge of the immediate phase information. In our future research, we will show the decryption mechanism of the current form of encryption to rationalize this theory and also to complete this research. I'd like to express my special thanks and gratitude to the Department of Computer Science and Engineering of University Institute of Technology, especially Dr. Shivakali Gupta, who gave me this golden opportunity to work in this field of graph theory, which also helped me in doing a lot of research, and I came to know about so many new things. I'm thankful to them. I'm making this paper on intelligent contraction because of my deep interest in graph theory, especially in the components of a graph. These are all the references which I have used in my presentation, and thank you for being a part of this conference.
Thank you, Indra. It was indeed a really nice presentation, and I should say it's a demand of the day that we need some sort of work for at least the privacy on the social media networks.
Yes.
Now, my first question is that, like, what you are trying to propose using some dummy kind of information on your network, and another thing is, like, whenever you are going on the second and third degree of contraction, Actually,
Yes, sir.
whether it will affect the actual user connections on the graph or not. That is what my question is all about.
No, sir. I have already shown that the original friendship network actually passed to the pairwise partitioning module, where we can actually preserve the pairwise relationships of the graph. I will show you a little bit. Uh, is my screen visible, sir?
Yes.
Uh,
Okay. I'm showing.
Visible.
Okay. For example, this is the original graph. And after the pairwise partitioning algorithm, we get the partitioning table as a result, where we have preserved the pairwise relations in the form of a table, where the non-essential partitioning set actually implies the information which is not present in the graph, and the essential partitioning set implies the implies the essential informations in the graph, where that means the edges are present in the graph. The essential partitioning sets actually implies here.
Okay.
So
So
during
let me
yes.
interrupt you. What sort of improvement you are trying to propose in the real time scenario? Or say, for example, on Facebook, like you want to propose.
Yes, sir. Can you
Yes,
ask me
let
again?
me repeat you. What sort of improvement you are trying to propose in terms of any real time or real time case scenario? Say, for example, Facebook. We have lots of network on the Facebook. Maybe we have lots of mutual network. And as you suggested that like hackers are trying to take this particular link that maybe say, for example,
Yes.
I'm connected with few other friends and they try to reach to some final destination. But your proposed method can help you to encrypt this all, and it will not allow you allow a hacker to reach up to that state. Is it so? Have I understood properly or not?
Yes, sir, you have understood properly. Recently, Facebook incorporated a new mechanism, that is, you can hide your friends, but
Okay.
that particular mechanism is only for the front end, and attacker can easily identify you and your friends, and from this they can hack your friends, and from that they can hack his or her friends. So this is nothing but a chain, and the hacker could easily do that. So my prime intention is to secure the entire Facebook network by extracting some community from Facebook, which is nothing but the subgraph of Facebook, and try to encrypt that particular community. And like this way, I think we can entirely secure the Facebook network, so an attacker could not predict the actual network by seeing this actual encrypted network. But uh, all the necessary informations should be kept inside this essential partitioning table, which and during in this short paper, I have not discussed complete the decryption process, and if I will show the actual decryption process, you can see the information is not all the information is not lost in the encrypted graph. We can get back the original graph in polynomial time, and I have already tested in
How you
few number.
have implemented this framework? On which particular platform you have worked on this?
Uh, Actually, I have tested on a small subset of this graph due to lack of funding and lack of infrastructure in our university. So I have manually tested in my room, using only a pen and paper, on an average 50 nodes. I have tested my algorithm, and it takes about around 3 days to complete a survey of this encryption and decryption process. But we can implement this algorithm, and I have mathematically tested the time complexity of the entire encryption and decryption algorithm, and it is and I have proved it mathematically that it can be done in polynomial time. It can be done, and more precisely, it can be done in cube time, which is nothing but a polynomial time encryption process.
What exactly the significance of some duplicate profile on your presentation? Like you suggested some duplicate profiles.
Duplicate profiles in the sense the merged vertices. For example, I have in the initial degree of contraction, I have shown Shoham and Pius as a contracted vertex. So if I will pass the contracted vertex of the form Shoham and Pius, the attacker, if an intelligent attackers may predict from the merged vertex, that is Shoham and Pius, the attackers may predict the actual vertices previously shown of the previous contraction layer. The attacker may predict, but if I replace the contracted vertex with a dummy vertex, which is nothing but a fake information, and which returns something null, which returns something void, which does not return any valuable information. So I have and by seeing this seeing the dummy vertex or dummy vertices, it is quite impossible for an attacker, and lots of permutation and combination behind that, so it is quite impossible
Okay,
for an
got it.
attacker to
I
predict the
wish you all
actual
the best
network.
to implement this on a real social network and try to help the society to protect themselves on the online interface. Thank you so much. It was an interesting presentation and interesting work. I wish you all the best for that. Thanks.
Thank you, sir.
So next paper is like 062. Paper ID is 062, but it's like a pre-recorded video. Author has submitted pre-recorded video, and because of time constraint, because of time limit, I just want to skip that, because we have to start the next technical session, that is S7 at 12 o'clock. So I just would like to thank you, Dr. Kiran Trivedi, for sparing your valuable time for our icSoftComp. Although you have a very busy schedule, and you spare time for us. Thank you very much.
Thank you so much, sir. Thanks a lot. Thanks to all of you. So may I leave now, sir?
Yes, sir. You may leave now.
Okay. Thank you, sir.
Dr. Saini, I made you the presenter, so you can share your screen. Okay, madam.
Hello.
Yes, you are audible.
Hello. Good afternoon, sir.
Good afternoon.
Yes, yes.
Okay. So shall we start?
Yes, yes, definitely.
Okay, ma'am. Just a minute. So next technical session, that is S7, and we have session chair as a Dr. Rasmi Saini. She has pursued his PhD from the IIT Roorkee, and right now she is working in a computer science and engineering department of GB Pant Engineering College, Garhwal. Her research interests are mainly the image processing and like networking, machine learning, and remote sensing. I welcome you, madam, to this icSoftComp. Thank you very much for sparing your time for us. So we have like four papers in this technical session. Out of these four papers, two author of the two papers are going to present their paper live, and the authors of two papers have submitted that pre-recorded video to us. So I think I need to call the author of first paper, that is paper ID with the 093. So Aritra Bandyopadhyay and Devdat Das, are you there?
Yes, sir. I am Devadatta Das. I am present here.
Just raise your hand if you can.
Okay, sir. I do on my video. Yes, sir.
Okay, just a minute. I need to make you the presenter so that you can share your screen, PPT.
Okay, sir.
Can you tell me your ID, team ID?
Wait, sir.
Or just raise your hand.
Okay, sir.
Not in that, in a Microsoft Teams.
Uh,
Okay, no problem. Just tell me your ID.
Sir, paper ID or Microsoft ID?
Microsoft Team ID.
Wait, sir.
Just a minute. From here I can make you presenter. No problem. It's a 232.
Yes, sir.
Sorry for that. Okay, now you are the presenter, so you can share your screen.
Okay, sir.
You have 12 minutes to complete your presentation, and we have 3 minutes of question answer.
Okay, sir.
So Dr. Saini, now I give you the control for this session.
Sir, the screen is visible?
Yes, your screen is visible.
Okay, sir. Shall I start, sir?
Yes, it's okay. Now everything is fine. You may start your presentation.
Okay, sir. Good afternoon, sir. Respected sir, respected ma'am. My name is Debodatto Das. I am Assistant Professor of Hooghly Engineering and Technology College, Hooghly, West Bengal, India, in the Department of Computer Science and Engineering. First of all, I say thank you for giving me this opportunity to present my work in this conference. So now I want to start my PowerPoint presentations about my work. The name of my work is a fuzzy rule based directional approach for salt and pepper noise removal with edge reservation. Okay. So in first slide, the abstract. So in abstract, we define the whole work in a short summary. So the first point is the existing system is available for the fuzzy filtering techniques for the noise reduction deals. That means by this existing system, it is available for removing the noise reduction, and it is always deal with the noise reduction procedure. So the proposed methodology presents a new technique for removing a filtering thin tail and intermediate filter noise by using a fuzzy filter. And also we can say the additive noise is removed by a new fuzzy filter. That means by this proposed methodology we can remove the additive noise. Okay. So introduction. So at first we have to know that what is image. So image is ubiquitous in the modern digital world. We can share any image in the social media like Facebook, Instagram, Twitter, WhatsApp, etc. So in this project, we had to work in the noise, about noise. So what is image noise? Like, we can say image noise means a random variation of brightness or color information in images. That means changing the brightness and color information in the images. Or also we can say the image noise is an undesirable product of an image. So how to produce the noise? So basically noise is produced by sensor and circuitry of a scanner or digital camera. There are many type of noise are presented in this field like salt and pepper noise, Gaussian noise, impulse noise. So here we discuss about salt and pepper noise. So what is salt and pepper noise? A salt and pepper noise is a type of impulse noise, and when certain amount of black and white dots are appeared in the image of the screen, on that time we can say that salt and pepper noise is arrived. So in objective and literature review. So in objective we can say that the image analysis process is understood by this proposed model, and also the corrupted pixels, that means the noisy pixels, can be removed by this method from any image. Or the how to remove the image noise, and that is we have to learn that how to remove the image noise from a noisy image. That is also we have to learn from this technique. And it is also to appreciate the differences between the restoration and enhancement technique. So in literature review, the 14 reference papers that are shown in my screen, we studied in previously before performing our work, and it was very helpful because we collected some very helpful techniques from those reference papers. So now in this slide we discuss the flowchart of noise detection procedure. Before noise correction procedure, we perform the noise detection procedure. So in noise detection procedure, at first we take 3x3 kernels. That means pixels block or image matrix, anything. That the name of the pixel block is SMNIP, and the center of the pixel block is denoted by X, and also the intensity of X is denoted as PIMX. And also we take the another binary flag image matrix. The name of the binary flag image matrix is SMNIPX, but the size of that matrix is same as just like the previous 3x3 block of pixels. We take the binary flag image matrix only for one reason, because all the values are filled with the 0 value in this image. So now we have to check the detected pixels at first. So we can perform the if then statements. So if PIMX equals to 0, then 1 represents the corresponding pixel location of the binary flag image matrix. If PIMX equals to 255, then 1 represents the corresponding pixel location of the flag image matrix. If 1 less than PIMX less than 255, then 0 represents the corresponding pixel location. 0 means a noiseless and 1 means noisy. So by checking these statements, if yes, then we can say the X is corrupted pixels and the value of flag AB equals to 1. Or if no, then we can say X is an uncorrupted pixels and the value of flag AB equals to 0. The noise detection procedure is completed successfully. Then in this slide we discuss about our work, the proposed methodology. So here in this slide we inserted 4 pictures. So in noise correction methodology, at first I discuss about figure 3. So in figure 3 we insert a 3x3 block of pixels, and here in the image a center pixel is defined by PQ. So for performing the noise correction procedure, so at first we have to perform the fuzzy derivation process. So what is the fuzzy derivation process? A fuzzy derivation process means we have to calculate the luminance value of the difference in the 8 possible directions in a 3x3 pixel block. So what is the luminance? Luminance means how much amount of light can travel from a location. That is called the luminance. So after performing the fuzzy derivation, we have to perform fuzzy smoothing. So what is fuzzy smoothing process? A fuzzy smoothing process means after completing the fuzzy derivation process, we have to check that in the luminance difference value that which are the noisy pixels or non-noisy. That means if there is no edge on the luminance difference value, those values are taken for the correction component with the help of the neighboring pixels values. That process is called the fuzzy smoothing process. So before performing the fuzzy smoothing process, we have to perform many other things. Just like we have to calculate the standard deviation. Standard deviation means dispersion measure of any image in the gray level intensities. Or we have to perform rectification values for the correction component. And also we have to find the membership grade. The membership grade, what is the membership grade? A membership grade means a graph. A graph defines and each point of input space is mapped to the membership value between 0 and 1. Input space, what is input space? An input space means an input space is the universal of discourse. Universe of discourse or universal of set. We can say just any one of them. Okay. So now in the next slide, it is the flowchart of noise correction procedure. So in this slide, we discuss about the whole noise correction procedure. So in noise correction procedure, at first we have to define the two variables. First x equals to 0 and second y equals to 1. 0 means noiseless and 1 means noisy. That is discussed in the noise detection procedure previously. So now we have to consider a 3x3 block of pixels at the center of the block, and the center of the block is defined by a PQ. So in the first process, we have to perform the fuzzy derivating. So what is the fuzzy derivating process? That is discussed in the previous slide. So after performing the fuzzy derivation, the Luma difference value is calculated in all 8 possible directions, and that directions are shown in the flowchart. That's are I, J, K, L, I, K, I, L, J, K, J, L, and that are collected from the 3x3 block of pixels. So after performing the fuzzy derivation process, then performing the fuzzy smoothing. So before fuzzy smoothing, so at first we have to compare 3 directions. That name of the directions are T1, T2 and T3. So if we perform the if then statement, if T1, T2 and T3, any 2 or 3, if small, then we say that the membership grade of MTPQ is small. What is membership grade? That is discussed in the previous slide. If no, then membership grade of MTPQ is large. After performing this process, then we have to consider another 5x5 block of pixels, and then being at the center of the block. We have to taken the 5x5 block of pixels only for one reason. We have to calculate the standard deviation SD. What is standard deviation? That is discussed in the previous slide. So after calculating the standard deviation, we have to perform the multiplication process between the standard deviation and amplification factor. The amplification factor is denoted by Z. So SD equals to Z for Z into standard deviation. So we perform this process because we want to get the large value for the correction component. When we get the large value, that is added to the correction component for the final corrections. And also we have to comparing the T1, T2 and T3 directions, that are the rectification value that are also used for the correction term. So now we have to calculate the correction component in the direction of T, that is a fraction of ATPQ. So after all of this completed, then we have to specify the following fuzzy rules. So what is the fuzzy rules? A fuzzy rules is nothing. Fuzzy refers to a things. It gives us a valuable flexibility. Like suppose the example in Boolean algebra, 1 represents an absolute truth value or 0 represents an absolute false value. But in fuzzy logic, there is no absolute truth or false. In fuzzy logic gives us a intermediate and intermediate value. By this intermediate value, we have to say easily that it is a partially true or partially false. So that is the definition of the fuzzy logic. So now here we applied that process. So we specified the following fuzzy rules, and to obtaining the final correction in the direction of CTP and CTN. So what is CTP and CTN? CTP means the positive correction component in the direction of T, and CTN means the negative direction component in the T direction.
Interview, sorry for. So just conclude your paper in 2 or 3 minutes.
Okay, sir. Now after completing the whole calculation, we have to calculate the average value of all the pixels. So in the results and discussions, we inserted the black and white pictures with 40%, 60% and 80% noise density, and In next slide, we inserted the tables of the values and the comparison of PSNR SSIM values and also average runtime between the proposed filter and other 4 filters, and the other 4 filters are taken from the references papers. So that is my work, and in the conclusion part we can say the fuzzy filtering method works is very good, but then the other state of filters in the noise removal procedure, and also we can say the smoothing process is able to resolve the edges, that is the quite extent of the images. And also important things that we denoted that the average execution time is much more lengthier than the few other filters in this field, and this proposed methodology is limited to work on the grayscale image, but also it is mainly designed to work in the medium and high density noise, just like a salt and pepper noise. So in last 2 slides, we we gave the references papers, and that references paper are very helpful, and we studied that references papers in before the performing our work. So that is my work, and I say thank you, sir and ma'am.
Sir, shall I ask questions regarding?
Yes, ma'am.
Okay. So thank you for your presentation. It was nice. My question is, like, first, I wish to know that that you have proposed some methodology. Will this methodology will also work for the real images? Suppose I capture the image, and the same scenario, it is having the data, because you have taken some already set up data, right? So will
Yes.
this methodology work for the real images?
Yes, ma'am. It will work.
Have you tested it on the real image data?
Sorry, ma'am. I can't hear you.
My question is, have you tested it on the real image data?
No, ma'am. I tested this. It was just like a black and white image because it was my first work. So I tested in a black and white images. But after performing this work, I can try it in the color images. My proposed methodology is tested in a color image or real image. I think it should be work.
Okay. My second question is that you have chosen the kernel size by 3 by 3, right? So,
Yes,
like, what is the reason? Have you tested other kernel size also in the same scenario, or you just taken it by default?
No, ma'am. I choose 3 cross 3 because the value is the in the small term. We get the small term value, so we choose 3 cross 3. But we can choose a 5 cross 5 or 9 cross 9, anything.
Okay. So on what basis you have chosen 3 cross 3?
Because
like,
I
is
choose
there
3
any
cross.
parameter?
No, ma'am, no. I choose 3 cross 3 because the when we calculated the value in a matrix that in a small way, so I choose 3 cross 3.
Okay. Okay. My another question is, like, you have used some smoothing operation, right?
Yes,
so
ma'am.
is there any loss of information after this operation?
No, ma'am.
In context of the original data.
No, ma'am. I don't remember, but I think no.
Okay. So this methodology will work also for the color image also?
Yes, I think so.
Because you have
It
applied
will work.
on the grayscale image, right?
Yes, ma'am.
Okay. So how many images you have taken for the experiment?
Ma'am, 5 to 10 images. But that images are also the black and white images.
Okay, grayscale images.
Yes.
Okay. Okay, so that's all from my side, Professor Patil. If anybody, other people wish to ask, they may ask.
Any questions from the audience? No questions? Okay, then may I ask the author of the next paper, madam?
Yes, sir, sure.
So next paper ID is 217. Akhil, are you there? Are you present over there?
Yes, sir.
Just a minute.
Sir, can I off the presentations?
Akhil Krishna, na?
Yes.
Okay, now you are presented, so you can share your screen.
Sir, can I off my screen?
Can I? Yes,
Okay, sir.
we can.
Okay, sir.
It
Okay,
is
sir.
visible.
Okay, sir. Fine. Is my screen visible, sir?
Yes, it is visible. You may continue. You may start.
Yes, a very good day to one and all present. I am Akhilesh Krishnan from the Department of Computer Science and Engineering of SRM Institute of Science and Technology. The topic of my paper is KTS VidRec, a knowledge-based topic-centric semantically compliant approach for video recommendation on the web. This paper is co-authored by Mr. Jarad Deepak, who hails from the National Institute of Technology in Trichy. So first, I'll proceed with the abstract. So in this age of an increasing user base of the internet on a daily basis, there is a surplus of video content being available for consumption. Especially in this lockdown, you would have met with the problem of finding a lot of videos to be consumed, but a very less time and the relevance of the videos being lesser due to the surplus of videos being present on the World Wide Web. So we have proposed a framework which is KTS VidRec. It's a semantically compliant approach for video recommendation, and it's mainly based on query-centric approach, and it incorporates entity population using the structural topical modeling and entity aggregation from different bases, which are the information bases. Then the computation of semantic similarity is carried by the Albert-Leibler divergence, which is the KL divergence, NPMI, cosine similarity, and the Jaccard similarity. The KTS VidRec is a semantically infused machine learning model, and it uses algorithms like XGBoost, which is used to classify the popular video categories from the video dataset that I have used. Also, the linked open data cloud is used for the enrichment of categories. As I said in the previous slide, the motivation for the project comes from the availability of a lot of videos being present on different websites for our consumption, and a lack of relevance of the video content for the people who are about to view them. Also, there has been a meteoric rise in the users of the World Wide Web, and there has been an explosion of the amount of data found on the internet. So, as a result, people have not been able to find videos that suit their interests and of their likings in the case of websites like YouTube and also other OTT platforms. And the existing strategies which are used in recommendation of videos don't work particularly well with the current structure of the web, which is the semantic web 3.0, which incorporates metadata into the current structure of the web. And there is a need for a semantically inclined approach for recommendation of content from the World Wide Web and the use of knowledge representation schemes to make the recommendations less complex. The contribution. We have contributed to this project by proposing a semantically compliant video recommendation system, which uses knowledge representation and reasoning schemes that help to tackle the highly linked hierarchical data. What we mean by hierarchical data is highly interlinked data, which are in the form of trees, where one form of data depends on the other data for higher relevance. We have used the structured topical modeling to find newer topics and to find the similarity for a single category of video from different websites, and the XGBoost and computation of semantic similarity using the different semantic similarity measures that I stated in abstract. So the proposed system is focused on the user query instead of being user-centric. mainly focused on being query centric, and it depends on the queries that are posed by the user to ultimately offer the video recommendations, which makes it much more relevant to the user. The use of STM and a query centric approach helps the model achieve higher performance metrics compared to the other models which are currently prevalent in the industry. So these are the literature surveys which resonates with our work. The different authors for these works are Davidson et al., Delview et al., Shen et al., and Lee et al. So this paper by Davidson et al. Is like the first work on video recommendation in YouTube. They have put forward a system for recommending YouTube videos by making use of the user's activity on the site, and the recommendations are evaluated using the click-through rate, the previous clicks. They evaluate the recommendations based on the previous clicks of the user, and they recommend relevant videos based on this metric. So the disadvantage of this method is it uses a graph-based approach, which is highly complicated and takes a lot of resources for computation. Okay, Delview et al., they proposed a system to recommend the videos based on stylistic features. They extracted some stylistic features based on the videos. I guess there were 11 stylistic features, and the visual aspects which were extracted from the video. So the disadvantage of this method was there were no proper strategies used for extracting the stylistic feature. Then the third proposed approach is of Chen et al. They created a personalized video recommendation system that made use of the tripartite graph propagation for recommending personalized videos to the user. The disadvantage of this approach is the user-centric approach instead of query-centric approach, and the usage of complex tripartite graph traversal. The final methodology used large-scale content-only video recommendation system, which used deep learning and neural networks, and further used video embedding and similarity learning, which were based on the video content. Since this approach is the disadvantage of this method is since the approach is based on deep learning, it's very difficult to find what kind of output that goes to the system, and hence it's a blind box approach. Yeah. This is the architecture of our implementation. Firstly, the query terms are subjected to pre-processing, and the query words are obtained. In the step of pre-processing, we use all the NLP techniques of tokenization, lemmatization, and stop word removal. The web usage data of the user is also used to know more about the user's interest. The query terms are obtained, and the entity population is done based on the structural topical modeling. That is finding newer topics for the suggestion of the user. From that entity populated query terms, we do entity aggregation. That is much more entities are added using the freebase, which is a data repository or maybe a data dump, which is done using the freebase API. Further, another stage of entity aggregation is done from popular video repositories like Amazon Prime, Netflix, and other OTT services, from which the video categories were crawled by the Beautiful Soup API. The YouTube dataset we used were the YouTube statistical dataset, which contained a lot of statistics about the video data, like, shares, comments, and the dates they're posted, the countries of posting, etc. We obtain the categories from the YouTube video dataset, and we enrich the categories using the linked open data cloud. The linked open data cloud is a large data cloud where different data are interconnected using connections, and it was accessed using the LOD Cloud API. And from the relevant results taken from the linked open data cloud, we enrich the categories which were already obtained from the YouTube dataset. And the categories which are obtained from the YouTube dataset is subjected to classification using the XGBoost, which also makes use of the query terms obtained from the user query and the web usage data. And we create a top 50% of classified video categories. In the second phase, what we do is we compute the semantic similarity. We compute the semantic similarity between the query terms and the categories obtained from the dataset in the previous step, and we take the categories and formulate a hash set of similar categories. Further, the semantic similarity is done using various semantic similarity techniques like the Jaccard similarity, cosine similarity, and NPMI similarity with the video categories in the hash set and the video categories that were obtained from the top 50% of the classified videos. When we do this, we obtain a final set of category of videos that are much relevant to the user, obtained from all the sources. We take those categories, we arrange it in the increasing order of semantic similarity, then we recommend it to the user. So for the implementation of this project, the language used was the Python of 3.9.0. The IDE used was the Kaggle IDE. Sorry, the IDE used was PyCharm, and the dataset was taken from Kaggle. The dataset used for the model is the trending YouTube video data statistic dataset, which I told already. Its parameters are based upon various evaluation, like the title of the video, name of the channel, time of video upload, and the various tags involved in the description. So we would have seen a lot of tags which are available in the description of the YouTube videos. Further, the number of views, the number of likes and dislikes were also used as an evaluation metric. The Python 3.9.0 was used to implement the proposed KTS Vidrec architecture, and Kaggle's IPython notebook was used as the IDE and was used to design and implement the architecture. The Kaggle's IPython notebook provides an NVIDIA Tesla P100 GPUs, which was much useful for the running of the model. And we use 20 gigabytes of disk storage for data and a 16 GB of RAM, which could provide high performance computation tasks. So this STM library is actually our library. So it was achieved and it was brought into Python using the single subprocess call, which allowed us to use the R library in Python. I also told you that the freebase API was used when entity aggregation, that is adding of more entity and more categories were done using the freebase data dump for entity aggregation. For that, the freebase API was used. And in the final part of entity aggregation, where I used the categories from other video repositories like Netflix, Amazon Prime, Vimeo, MX Players, etc. A HTML-based web crawler is based on Python. It's called a Beautiful Soup, was used for this project. So now I'll go to the result analysis. As you can see, in comparison with the other different proposed methodologies, the KTS Vidrec approach had an accuracy of 94.87%, precision of 91.18%, a recall of 93.02%, F measure of 92.98%, a false discovery rate of 0.05, and an NDCG of 0.96. The first thing is the YouTube video recommendation system uses a coefficient-based traversal of graph where the candidates are generated and a MapReduce function is used for further ranking and the recommendation of the video. This is a YBRS system. The user relevance is an important strategy in this approach, and the graph-based, approach makes this approach a very highly complicated one, and the user relatedness is evaluated using the pre-visits of the other videos, rather previous set of results, which yields a lower relevance score because it only satisfies the pre-visitation count. In the second content-based video recommendation system, they use stylistic features of the videos. There are 11 stylistic features incorporated. The main drawback of the system is it's still non-semantic and does not work well when the density of the dataset increases. And moreover, a KNN algorithm used in this approach is a quite naive approach, and stylistic feature extraction requires proper strategies for the extraction of features, and there is always scope of improvements in such systems based on the above statistics.
Okay.
Yes, sir.
Please, I sorry for that, but just complete your paper in 2 minutes.
Yes, sir. Sure, sir. Finally, in the PBRGP model, they use a tripartite graph traversal, and a pair of graphs are used to connect users and videos. Most importantly, instead of a query-centric approach, they focus on a user-centric approach where a user is given more importance than the query. While the user feedback is important for a system like this, highly driving something based on the user is a tedious task, and the tripartite graph traversal is much more complicated. So there is always scope for making such computationally expensive approaches efficient. If we see the graph in figure 3, the data set which we use in other models too, and the percentage of the precision versus the number of recommendations for a different number of recommendations were tested, and the percentage of precision was found to be much higher than the other models. As a conclusion, a novel semantically inclined video recommendation framework, which is KTS Vidrek, is proposed. And as I said, it uses a query-centric approach for video recommendation based on the queries and web usage data. It incorporates entity population using STM and the further knowledge representation by entity aggregation and using other video repositories. The YouTube video trending dataset was used as the video dataset, and the top 50% of video categories were used, and the LOD cloud were also used for the project. And it can be concluded that the proposed approach had better performance compared to other baseline models due to its semantically driven approach and use of knowledge representation. The proposed model had a very low value of false discovery rate and the highest value of NDCG, which is normal discounted cumulative gain, which focuses on the relevant results obtained, and it is an efficient and semantically sound solution for the recommendation of videos on the web. These are the references that we use for the project. Thank you for giving me this opportunity to present my work.
Any questions from the audience? No question from the audience. Dr. Saini, if you have any questions.
So thank you for the presentation. My question is, like you have mentioned somewhere that in literature review, some researcher have used deep learning techniques, right? So what is the reason that you have chosen the XGBoost that comes under the category of ensemble method? Then why you didn't go for the deep learning approach?
Ma'am, the XG boosting technique.
Am I audible?
Yes, ma'am. Yes, ma'am. You want to know why I use an XG boosting technique instead of deep learning techniques, ma'am?
Yeah.
Ma'am, while getting the classified video categories from the YouTube video dataset and the other sources like user queries and the web user dataset, the XD boosting model provided a much more better classification of these categories.
Okay, but my question is like, if we are having 5 classifier, right? Either they belongs to the machine learning category or they belongs to the deep learning category. But if I have not implemented it for my own work, right? So I cannot conclude like this particular classifier is giving the best result because we have not implemented it on my own work. So how you can say that?
Yes.
Okay. And my second question is like you have used XGBoost classifier, but as it is a supervised classifier, right? So it required the label data as well as it required the categories, like how many classes you are going to like form out of the raw data or whatever it is the information. So how you have identified the number of classes and how you have labeled this data? Because labeling is very important concept regarding any learning mechanism.
Yes.
Am I audible to you?
Yes, ma'am. But it's cracking a little bit. Your voice is cracking.
Okay. Should I repeat the question?
No, ma'am. You asked about how I took use the label data for this XG boosting.
Yeah. And number of classes.
Okay. Are you there?
Yes, sir. Yes, sir. Yes, sir. I'm
So
facing
you
a
are
bit
thinking
of
of.
problem.
So,
Hello.
yes, you are audible. You can reply.
I can say that the data labels used were from the categories that were obtained, but I am not very aware of the classes that I use.
Okay, actually, I just would like to mention it. Like when you are saying any kind of the supervised classification, the number of categories are depend by the user, like the analyst. Okay, so it is like the one of the must known parameter that you should always know.
Yes.
Okay, my last question is in this context, like as you know that the parameter optimization or we can say the parameter tuning is very important concept regarding the machine learning or we talk about the, any kind of the learning phenomena or learning scenario, right? So have you done any kind of the optimization or parameter tuning regarding the XGBoost? Because there are the many parameters that require the optimization for the XGBoost.
Ma'am,
The classifier, the
in
number of
this
the,
I have not
yeah.
done any kind of optimization, but in other works, I've used the Golden Eagle optimization algorithms for the optimization of the results obtained from the XGBoost algorithm. But in this work, I have not used any type of optimization algorithm for XGBoost.
Okay. Okay. So that's all from my side. So over to you, sir.
Okay, thank you, Akhil.
Yes, sir. Thank you, sir.
Next, paper ID is 094. Author of 094, are you present over here? Mahima Punya?
Yes, sir.
Okay. So I need to play your pre-recorded video. Just a minute.
Good morning, everyone. Today I am Punya from JP University Vavnagar is going to present my presentation in conference of icSoft Competition 2020 with topic Utility Distribution with Measure of Probability Stress, Single Valued Stopping Information, Hybrid Ambiguity, and Information. Firstly, we'll be starting with the introduction, which will be containing some basic literature related to the topic. Then we'll be discussing some basic definition for your for the recall of the topic with the information present in the literature. Then we'll be discussing entropy, useful hypothesis, hybrid ambiguity, and the improvement measures in case of useful single valued philosophic information measure. Then in the end, we'll be ending slides with the conclusion and future works for the topic. Firstly, we know that the fuzzy entropy is a non-probabilistic measure based on membership function. Later, it has been discussed in 1972 by Luca and Termini, which introduced the new measure of fuzzy entropy based on Shannon function. With the help of these two theories of probability have been designed, the probability plays a significant role or important role in fuzzy entropy. Luca gave the entropy, which is given by equation number 1, where your gamma A denotes the membership function. Then it has been extended by Kaufman in 1980, and he gave a new measure, which is given by equation number 2. Then Howard and Chaward extended this measure in 1967. Kaufman measure in 1967 and gave his entropy, which is given by equation number 3 by M prime A in the case of fuzzy information measure, and is proposed with the help of these three entropy, which I am showing, plays an important role in the case of useful information measure, which was initially being generated by Shannon in 1948 and its deliberation is given in the reference 11, which is of the slide or the paper. In that case, it has been given that the quantity of information conveyed is directly proportional to the probability of the probability task. And the probability Shannon measure is been defined by m prime a minus log pa. This pa is your probability or the average information of all the event and is known as Shannon entropy. As we have already told in the introductory slide that we'll be discussing some basic definitions, then let's start with the ambiguity measure. Firstly, as I'll start with the ambiguity measure, I want to define ambiguity. Ambiguity is the uncertainty of an event or the uh, uh, method or the multiple choice discussion, everything which is about to happen or something. In this, your gamma A denotes the membership function of the set A in the inverse of M, and M must be lie in the interval 0 to 1. Your Y must, if it does not lie in A, then the membership function is 0. If your Y belongs to A, then the membership function is 1. If the chances of belonging to set A is 50-50, then it's 0.5. Then we'll be discussing neutral-suffix set. Neutral-suffix set consists of 3 elements: truth, neutrality, and falsity functions, where these three membership function must lie in interval 0 negative to 1 positive, and the supremum sum of these elements must lie in 0 negative to 3 positive. Then the single valued neutral suffix set. Single valued neutral suffix set is little bit different to the neutral suffix set, because neutral suffix set contains of infinite number of membership function or something, but in the single valued neutral suffix set they must contain only one element, and these element must lie in interval 0 to 1, not in 0 negative to 1 positive. Then the Shannon entropy, in that case we are consisting of n probabilistic measures of the event which is denoted by P1 to Pn, and the Shannon measure is denoted by MPI, which is equal to minus k sum of Pi log Pi, where k must be a positive constant. Then a measure is said to be entropy when it satisfies the following 4 properties, in which your entropy of M prime single value neutral suffix set is given by Em prime A, and it is equal to 0 when your membership falsity and your truth membership falsity and neutrality function is equal to 0 or 1. Your membership entropy measure is equal to 1 when these 3 elements is equal to 0.5. When we are considering 2 single valued neutral suffix set A1 and A2, where A1 is subset of A2, then the entropy of A1 must be greater than equal to entropy of A2. In that case, your truth membership function must be less than your A2, and your falsity must be less than your A2, but your neutrality must be greater than your A2. Then we'll be discussing, then the last exam is that the complement of the complement entropy measure and the original entropy measure must be equal to each other in case of your entropy measures. In this, we'll be proposing the following 3 neutral suffix information measure, which was firstly defined by Luca in the case of fuzzy set, but we'll be defining it in the case of neutral suffix single valued neutral suffix information measure. In this way, we will be able to extend the area of solving problems, as in fuzzy sets we only deal with the membership function, but in neutral suffix we are dealing with the 3 conditions, which certainly help us in solving many problems related to uncertainty or ambiguity. Then in this paper, we have designed entropy for our measure, which was firstly done by Hooda and Bajaj, again in fuzzy sets only, but we will be describing it in the case of neutral suffix set, and it is given by question number 5, as you can see in the slide. The condition is that your UI must be greater than 0, right? Then we have in this slide we'll be showing the that our measure is an entropy measure, as we have already discussed that our measure must satisfy all the 4 exams. We will be discussing all the 4. First was that entropy equal to 0 when it is your membership function equal to 0 or 1. and this slide it is coming 0. So it means that our membership function is valid, and it satisfies the exam first. Second was it equal to 0.5, then your ambiguity entropy must be maximum, that is 1, as is coming. The third was that if A1 is subset of A2, then your truth membership function must be less than A2. We are able to obtain that condition also. And the complement, in case of complement, your entropy must be equal to the complement entropy, that has also been satisfied. Similarly, we can show it for the neutrality and the first degree membership function, which we are not showing in these slides. But with the help of this membership, we can already prove that if one element is satisfying all the properties, all the two are satisfied. Thus, we observe that all the exams are satisfied. Now we know that the divergence measure. The divergence measure for single-valued neutral suffix set is basically dependent on all the three properties which is given below. Those are two positive and symmetric single-valued neutral suffix sets are compared. Divergence is equal to 0 when your two sets coincide. Divergence is inversely proportional to the similarity between the two sets. As the similarity increases, the divergence decreases. Then the simplest form of fuzzy divergence was introduced by Bhandari and Pal, which is given by reference number 28 and is given below. Then in our case, we defined it in the case of neutral suffix, it satisfies our condition, and it also satisfies the symmetric measure, and it is defined by question number 8. Then the theorem for the divergence measure is that this measure must be greater than equal to 0. For that, we have taken the assumption that your membership function equal to E. For A set, the membership function for B set is F, and your UIPI, that is universal, useful, and probabilistic product is equal to. Then we substituted all the values, and it has been proved that this is greater than 0. This satisfies our theorem. Then we'll be discussing now the hybrid ambiguity for the useful measure. In this case, we'll be considering two sets, information sets A and B. And these two sets must satisfy the following conditions. Those are: first, the entropy of set A defines the ambiguity for the given set. Secondly, the difference between A and directed divergence of B is calculated by IAB. Then your hybrid ambiguity must be equal to entropy of A and IAB. The hybrid ambiguity for the truth membership function is given below, which is HA membership function is equal to 1 by 2 and log 0.5. Then your defined useful measure, which has been discussed below. Then remarks is that it may be noted that we can establish a relation between entropy and divergence and of two single-valued neutral suffix set as shown. That is, if gamma B is equal to 0.5, then your gamma AB equal to this. Then the relation should be, that is, half minus entropy of single-valued neutral suffix set. The useful information improvement measure for three single-valued neutral suffix set under consideration can be explained as followed, in which we consider A and B two sets, where A is estimated from set B and we revise to set C. The original and final ambiguity by I prime AB and I prime AC is then reduced ambiguity for truth membership function is given by this. Similarly, we can prove it for your falsity and neutrality membership function. Similarly, then this is called your useful single-valued and neutral suffix information measure. Now, the conclusion or the future work for the current proposed methodology for single-valued neutral suffix set is: in this work, we have successfully established or validated our proposed measure, named as probabilistic single-valued neutral suffix useful information measure. useful divergence measure, hybrid ambiguity, and useful information improvement measure of single-valued Neurosophic set. All these measures have been explained and validated with the help of well-established exams present in the literature and the numerical exam, in which we are taking your elements or something. In future work, we can extend this methodology to the decision models, can further be studied as proposed measure, and the concept of lengthened multiplier can accordingly be implemented for formal deviation in future work in reference with the work carried out by Hooda and Bajaj in 2010. In the process of moving forward in the direction of deviation, it has been proposed that we can need to take the multiplier in the form of the format of different complements, that is this. In this, we are again showing in case of membership function only, but for the neurosophic, we have to take your falsity and your neutral membership function also. These are the references used. Thank you.
Any questions from the audience? Author of the paper is present here, so you can ask the question. No question from the audience. Okay. Dr. Saini, if you have any question.
Okay. Am I audible?
Yes, you are audible.
Hello.
Yes, you are audible.
Audible to you, sir?
Yes, ma'am, I'm present.
I'm not getting the response.
Saini, are you here?
Can you hear me?
Yes, I can hear you. We can hear you, madam. Dr. Saini, are you there? I think is there. Okay, any questions from the audience? Again, if you have, then you can ask, else we can stop here this technical session. Questions? Dr. Saini, if you can hear.
Hello.
Yes.
Hello. Am I audible?
Yes, you are audible.
Oh, okay. I think there was some network issue. That's why. So, author of the paper are present here.
Yes,
Yes.
yes, ma'am.
Okay, fine. So my question is very simple question, that what is the novelty of your work?
So, no,
That
ma'am,
how it
no.
is different from the previous work?
Okay, ma'am. Ma'am, actually, the previous was done on the fuzzy set, and fuzzy set only deal with the membership function. And what is membership function? The membership function is the thing in which we get the maximum amount of the probability of happening an event. But it is not able to deal with the probabilities that what is the probability of getting not happening event, or what is the probability of getting 50-50, like which is I call that neutrality. So my novelty is that if through this method we're not only able to calculate the probability in case of the membership function, but we are able to calculate the that for the case of the non-membership as well as the neutrality, which will play a great role in planning anything related to the probability of any event which we are planning in future or something.
Okay.
Yes, ma'am.
So my next question is what is the limitation of your work? Because you
The
have elaborated the various parameter and the usefulness of your work. So is there any limitation regarding your work?
Before that, I can just say that if the limitation is that like in Neutrosoft, you are able to deal with only three things. It is happening in the case of sets, but it is not
Okay.
yet designed in the case of the graph or something, which will be very helpful in the computer science or any other technologies. So I am planning to work in this direction, but I still working on the sets only so that I can get all the parameters related to it.
Okay.
Yes, ma'am.
So that's all from my side, Professor Patel. If anybody, over to you, if anybody from the audience wish to ask the question.
There is no question from the audience. So, Dr. Saini, thank you very much for sparing your valuable time for us and remain here as a session chair for icSoftCom. Thank you very much, madam.
Thank you so much, sir. And I wish you a grand success for this conference. And I'm really thankful that you invited me as a session chair for this conference and wish you very all the best. Thank you so
thank,
much.
thank you very much, madam. So we stop here. We have now a lunch break. So we'll meet again at 1:30.
Okay, may we leave, sir?
Dr. Jain, thank you for joining.
Hello, good afternoon, sir. Thanks. Well,
After a long time we are meeting.
I think 20 years, huh? How are you?
I am fine, thank you.
Yeah,
Start in 1 minute.
sure.
I'm checking whether the author of these papers are present or not. Okay, let's start. I think we should start, no?
Yeah, I'm ready.
Okay. So this like technical session at as